A very good morning, everyone. Welcome to the eventful Centenary Celebration of the Department of Mechanical Engineering, IIEST Shibpur. Today, we have a webinar on 3D printing by Webel Fuji Software, Center of Excellence in Industry 4.0, being conducted in association with Institutions Innovation Council. So, 3D printing is a process of making three-dimensional solid objects from a digital file. 3D printing could help us on many levels for our mechanical projects, like from developing our prototype to the improvement of our design and optimization of our inventory. 3D printing really offers great benefits with our mechanical parts. To proceed with the inaugural ceremony of the same, I would like to request our respected head of the department to welcome the audience.
Sir, you are not audible.
Yeah, now?
Yes, now audible.
Well, very good morning. We are happy to be able to organize this webinar on 3D printing in association with our Institute Innovation Cell as well as Webel Fujisoft Center of Excellence. I understand Webel's Fujisoft Center of Excellence has the state-of-the-art technologies in artificial intelligence, deep learning and machine learning, 3D manufacturing, cybersecurity, Internet of Things, and embedded systems. COE has the latest equipment from the world's leading supplier in 3D manufacturing. So we have rightly chosen a partner who will be able to deliver this webinar very nicely. And on behalf of the department, on behalf of the institute, let me welcome Mr. Chaudhary, the center manager of Webel Fujisoft COE, and as well as other dignitaries from their side to this inaugural session. Let me also welcome Professor K.D. Bhattacharya from our Institute Innovation Council. This webinar would create awareness, I hope, about 3D printing, and this should also demonstrate the fundamental technology and applications of 3D printing. I'm sure that our students will benefit immensely from this event. Let me also welcome other members of faculty from this department, from other departments of our institute, as well as our students and scholars who are participating in this webinar. So with this words of welcome, let me also wish this event a grand success. And I request the organizer to proceed further with the inaugural session because the director would not be available because he is engaged elsewhere. So let's, we should accept his absence. So Vidyut, please, you may proceed further with the event accordingly. Thank you.
Thank you, sir. Sadak, please continue.
Thank you, sir, for your warm welcome. Now I would like to request Mr. Anirban Chaudhary, sir, Center Manager, Center of Excellence in Industry 4.0, to speak a few words.
Thank you so much. A very good morning to everybody. On behalf of Center of Excellence, Webel Fujisoft Center of Excellence, I really appreciate the initiative by the IIST Shibpur. It's one of the most prestigious institutions in India currently. And we are really honored to be part of the centenary ceremony of mechanical department of this prestigious institution. On behalf of entire Webel Fujisoft Center of Excellence, we are really thankful. And we really wish all the best to the future of the country. I'm sure with the past records we have, IIST Shibpur is continuing. They are having that would be continued by the students in future also by the mechanical department and the students of the department. I would like to just add few words from Webel Center of Excellence, who we are and what the purpose. As the name suggests, OEBL Fujisattara Center of Excellence. We are part of Government of West Bengal Department of IT Electronics and MSME unit. So this is one of the largest center of excellence, in fact, largest center of excellence in terms of infrastructure and the facility currently in India, set up by a state government under Department of IT and Electronics. In terms of 3D printing and additive manufacturing, what we popularly call 3D printing as nowadays, as a mechanical engineering students, I think all of you must be knowing that additive manufacturing has become primary responsibility and primary focus for central government and the state governments. So different governments are actually coming up with different center of excellence facilities, and they are actually trying to implement this technology, adopt this technology by the industry in next 5 years down the line. We are in India, we are still very at the starting phase of the technology, but slowly and gradually we are picking it up. And as one of the main focus by the central government and state government, such kind of center of excellences are coming up in different states. West Bengal government, this initiative is one of the largest in India currently. So we are very much equipped with state-of-the-art facility in 3D printing, 3D scanning, and 3D designing as well. We have partnered with various industry leaders. So we have an association with industry. We have academic association as well. So our 3D designing as a partner is Dassault Systems. I think many of you would be knowing them because of Rafale and their aircraft and their designing part. So Dassault is one of the partner of the Center of Excellence. We have Stratasys. They are the pioneer in 3D printing and additive manufacturing technology. So Stratasys is one of our partners. And we have several other university foreign collaboration in the Center of Excellence. So yeah, I mean, this is really a good initiative, and definitely we wish every student to get trained into 3D printing, and obviously mechanical engineering students, their natural progression should be towards this technology. So whenever, I mean, as soon as I heard about the initiative by the mechanical department about this particular event, we were really excited to be part of it. We really wanted the students to know the technology, not only the technology, know the future, how the job market is shaping up, what is the career ahead, what can be done. I mean, especially the students from IIST Shibpur, they should be really getting into innovation more than just a simple job, right? So that is something really it can be achieved through this technology, because end of the day, this technology is still very new compared to other technology, but there are a lot of scope actually coming up. So I really wish and really look forward the students of IIST Shibpur to really get into this technology, and I wish all of you a very best, and really, I mean, it is again, we are really honored to be part of it. I will be present in the session throughout. Our faculty members would be primarily taking you through the session. At the end of the day, if there is any question answer, we have a question answer session already. So if there is anything, I'll be available. Even our faculty members would be available as well. If anything further, any student wants to know about 3D printing, or because this 3 hours can be a very short time to discuss everything in detail. So definitely you can connect with your faculty members in your college. Dr. Pal would be the right person, I think, to guide you all to if you need anything from us. We'll be really welcoming any kind of suggestion, feedback, or any queries from anybody. So thanks again. Thanks for inviting us into this great session. So with that, I'd like to just end my talk here, and I hope you'll enjoy this next few years. Next few hours with us with the session. Thank you. Thank you very much.
Thank you, sir, for your inspiring words. Now I would like to request Professor Kanika Das Bhattacharya, ma'am, Vice President of IIC 4.0, to address the crowd.
Okay. Good morning, all of you. Can you hear me? Can you hear me?
Yes, ma'am.
Yes. Okay. So I first take this opportunity to thank the Mechanical Engineering Department, the head, and especially Dr. Bidyut Pal for organizing such a very relevant seminar for our undergraduate and postgraduate students. Now, I myself, on behalf of the Institute Innovation Council, Institutions Innovation Council 4.0, and myself also the chairperson of the Industry Institute Partnership Cell of the university and a professor of electrical engineering, I think it's a very relevant topic where you require this help, this aid of 3D printing to give shape to your innovative ideas. Now, you being a mechanical engineer or civil engineer or whatsoever, whatever your innovative ideas, whether it works or not, this is the right way to build up a prototype and get it validated after you use the 3D printing and make a 3D model of it. I will just share one slide which I came across a few days back. It's very interesting. Can I share that slide? Or a picture from the web? Can I do it? Hello? Hello? Can I do that?
Yes, ma'am.
Yeah. I'll just share. Can you stop present, or can I share it just like that?
Yes, ma'am.
Okay. Yeah, you have to make me a presenter before that.
Ma'am, you are co-host. You can present.
Okay. Can't share content unless the presenter makes you the presenter. So it's written like that. So can you just help me to do that?
Okay.
Being co-host not able to present?
Now, ma'am, I have made you the presenter also.
Okay. So I will. Can you see the screen? Can you see the screen?
No, ma'am.
Not yet coming, ma'am.
All right. I'll just share the this to Vidut. Vidut can share it.
Sharing window might be difficult here. So maybe you
No,
have
no,
to
I will stop presenting and Vidut will just please share it. Vidut, I'm sending it to you. Just the link, just the link.
Okay.
Okay, I'm just sending it to you. You just please share it with the students.
Is it through email?
Yeah, through mail. I'm just sending it to you. It is very relevant for today, and they'll get a very excited looking at this. It's a startup from
And which email did you send it to?
your Vidut Pal. Wait, Vidut. Let me just give me the time. Vidut Pal at make.iists.ac.in. I have sent you. It is your Zimbra mail, I think.
Yeah, so it's not there yet. So
Yeah,
I'm just waiting. Maybe it's taking time. Yeah, I got it.
yeah. Can you share the screen, please?
That's the website, right?
You just click on take that link to the browser and just click.
Is my screen visible?
Yes, your screen is visible.
Yeah, so let's scroll through it.
Yes, একটু বড় করো, একটু just make it a bit larger. Yeah.
Nice one.
আর একটু নিচে যাও, Yeah. Correct. This is a 3D printed house made in 21 days. You can just see the details about it. Who has made it? It's a startup from IIT Madras, Basta, and Nirmala Sitharaman had inaugurated it. It's happened in 2022 only, in February. So this is from a startup in IIT Madras where they're being sustainable and eco-friendly houses. And this is the way you can really shape the country. Now, you can see the boys and girls you can always search IIT Madras and 3D printing, you will get this. And it is made by a startup, and that is what we are wanting. You generate your own employment, not to run after getting jobs. You create job opportunities. So with the innovative ideas and with the new technologies that you have, please go ahead. This is one direction which will make India proud. And Mr. Chaudhary from Webel, I have a humble submission to you. Can you just arrange our internship for our boys at your Center of Excellence? And it will be a good thing to work on real projects for them. So this is my submission today, and I think Vidyut will take you along, and he has started a very promising and ambitious journey with the students. Thank you very much. Okay. A report?
Thank you, ma'am.
Okay, finished. Thank you.
Thank you, ma'am, for your insightful words. Now I would like to hand over to Professor Vidyut Pal sir to present the vote of thanks.
Morning. Am I audible? Yes. So I thank you. I thank. So just a minute. So it's my opportunity, humble. It's my privilege and proud that I have been offered to ask a vote of thanks. I sincerely thank Professor Parthasarathi Chakraborty, Honorable Director Sir, IIST Shibpur, but he could not join today due to his other commitment. But his support is always there for this such kind of events. I also thank Professor Sudhir Ghosh, HOD, Department of Mechanical Engineering, for his guidance conduct this webinar. I thank Mr. Anirban Chaudhary and Mr. Putin Bhattacharya and Mr. Mahsudur Rahman from the Center of Excellence in Industry 4.0 for their participation and association with this particular webinar. I'm thankful that they have agreed to conduct this webinar for our students. I'm also thankful to IIC, Institution Innovation Council, for our students, for Institution Innovation Council, Professor Konika Das Bhattacharya ma'am, that she has taken keen interest also in terms of developing interest in 3D printing and also other entrepreneurship and innovation kind of activities that IIC is doing as part of their activities. I also thank all the department faculty members who have joined here in this particular webinar. Thank you for your time. And I also thank our colleague Santanu Das Mondal, who has been helping us continuously in this particular session. I also thank our student anchor Satakshi and Anishta, who has made this tireless effort to bring this presentation to you. And I also thank all the participants for joining and for your interest learning about 3D printing. So I hope this will, with this particular session, we are kind of end of this inaugural session. We will be moving to the technical sessions after this inaugural session. So I'm sure that in the technical session, it will be very enriching and a very successful event, successful webinar. So with this, if I have missed someone to acknowledge their contribution, it is probably unintentional. I thank you everyone, one and all, for their help, for their support, conduct this particular webinar. So with this, we come to the end of the inaugural session, but the next session is the technical session, the actual session of technical. So I would request Satakshi, please continue from.
I think Vidyut.
Yes, sir.
At the end, I think I should mention one good point about this event, which students may know. I didn't mention it earlier. I mean,
Okay.
when we approach Webel Fujisoft, they readily accepted it and to give this sort of, I mean, this is a kind of training webinar, right? And without any cost. So that is a nice gesture from their end. I must thank Mr. Chaudhary for that, right? And students, you can honor these resource persons from their side just by being attentive and by learning something. That is the thing that we are going to gain, both from our side as well as from Fujisoft. I think we all will be happy if the students learn something from this webinar. Thank you, Mr. Chaudhary, for that.
Thank you, sir. This brings us to the end of the inaugural ceremony. Now I would like to hand over the dais to the dignitaries from Webel Fujisoft Vora, Center of Excellence in Industry 4.0, to start the session on the topic 3D printing technology and application. An initiative of the government of West Bengal, the Center of Excellence in Industry 4.2 is being developed by Webel, Fujisoft Incorporation, and Vora Technology. The Center of Excellence brings together graduate students, professionals, startups, corporates, technology providers, and government to radically transform skill development as well as foster innovations. It is located in Rajarhat, Kolkata, India.
Now I would request the dignitaries from Webel Fujisoft to take over the session.
Yeah. Hello. Good morning, all. Can you hear me?
Yes, you are audible.
Yeah. Okay. So I will just share my screen. Is it visible?
Yes, it is.
Just I will do it in the full screen. Yeah. So I hope everybody can see this screen, my screen, and I'm audible.
Yes, screen is visible and you are audible.
Thank you. As a big thanks to IIEST Shibpur, with even with the Dr. Vidut sir. We have been discussing on this webinar segment for how it will be beneficial for the students and all. So a very warm welcome to all the students and all the teachers, all the dignitary peoples are here. So myself, Pratim Bhattacharya. I am here as an associate manager for applications, and I even also lead as a mentor for the Fujisoft thing for faculty as with additive manufacturing, and we can say as with the 3D printing segment. So already Webel has been introduced, like what is Webel, Fujisoft, and Vara. We'll come up with a very short introduction onto the part for Webel. And before that, we will cover up what kind of things we are going to learn today and what are the things we are going to exchange on the part. So our topics will be more focused on into like what is our facilities about us. We will have a very short discussion on it. Then after the 3D printing, how the 3D printing is working, subtractive manufacturing, which we are usually doing into the part, and additive manufacturing, difference between the both segment, then materials of 3D printing, technology, all the terminology which is coming into the 3D printing and which help into the modifications of the models and all. And then after for the design process, the complete design aspect, how the process is going, and the application and use cases of the part of 3D printing, what we are doing. So this is what about us comes up with like with Fujisoft Vara Center of Excellence, Webel Fujisoft. So it's a complete West Bengal government initiative, which West Bengal government and Department of IT Electronics and the Directorate of MSME, Ministry of Micro Small Medium Enterprise, Government of West Bengal. So they have came up with a plan with having a center of excellence where the partners will be doing into the development of the West Bengal complete community into the manufacturing segment, as well as the student prospect, where the student will be trained into the emerging technologies. So here, Webel, Fujisoft, and Vara, there are the three companies. Webel is one of our nodal agency, where Webel is a very well-known thing for all of us, which is our IT department, Webel controls on the segment, and we have Fujisoft, which is from Japan, which is the one of the independent largest system integrator company. They are doing the IoT segment, and they cover around 80% of the Japanese market into system integration, IoT, or even you can say like with the all the segment what we are doing into mobiles system, or even with the automotive, a complete IoT integration. Japan is one of the largest thing, and Fujisoft is one of the biggest company in Japan. And then comes with the Vara Technologies. Vara Technologies is a company where it's an Indian-based company. It's a Kanoria Foundation company, and Vara Technologies is a very niche company which focus into your blockchain, cybersecurity. So they are doing into the very new emerging technologies on the segment, and they are doing the blockchain things and with the cybersecurity into coming up with the all over like India, where they handle big government projects with Indian Army, then after with a lot of government, Indian Air Force and all. So these three companies came together as a joint venture, and where the Center of Excellence has been founded up. So Fujisoft and Vara is now running the Center of Excellence into for a certain level of time. So we'll move forward on the. So this is what our workshop, or you can say our day seminar comes up with the world of 3D printing, how the 3D printing coming up. So already ma'am has mentioned this house has been also in my presentation. This is with the house which has been first 3D printed house in India. So it's with IIT Madras startup. So they have developed this within a day of 21 days, where they have developed the entire building, the structure, the designing, everything can be done. So just you can imagine, like within 21 days, like not even a month, a complete house of such a big size has been completed within a certain time. So this is the 3D printing. What is the market capture of 3D printing? Like 3D printing is booming up in the segment. First, like it is having 3D printing is something which is completely evolved into various set of applications. One of the thing with the construction things which recently has been come up, which is a house 3D printing, or even like a sanitary 3D printing in various places. People are developing small bathrooms and all for the slum peoples with the 3D printing within even a single day, even less than a day. They are developing this kind of projects. So with the global market of 3D printing, if you come up, 3D printing has a very good market, and it is going every year. It is rising up by 20 to 25% of the market growth. With 28 to 2013, it has been already risen up to 24% of market growth in the Indian market, and even with the worldwide market, where you have a big market in just on 2017, the market size was around 8.5 billion, which is coming up to 2023 to 31.8 billion of market size. So this kind of growth is there into the 3D market, and you will be the persons, and you will be the coming up stage where people will be coming up and investing into 3D printing, and they will having a big of setups for the things. Even recently, Indian government in the month of February, in the end of February, they have launched this national strategy for additive manufacturing. So now with the making projects, people have started developing other big industrial grade machines in India, and it will be into a stage where Indian government is looking for to change the entire manufacturing into the 3D printing side, where there will be 1,000, 2,000, 3,000 pieces of 3D printers, and it will be doing a regular grade production day to day. So that's a vision of the Indian government, which Indian government has already started with the national strategy planning of additive manufacturing in end of February. And it has been now hand over to a lot of big institutes like CMERI, then after with CMTI, which is the machine development companies in India and the government based. So they are now growing with few fully fledged 3D printing market in India. Coming up with the career aspects of 3D printing, where students, this is the most important thing, where you can involve into the things, how you can see yourself into the career aspect, how you can develop yourself for the career aspect. So not only with the mechanical student, obviously a mechanical, that is a 3D printing is a machinery things, where only the mechanical students will be having a very good interest on the part. But yes, 3D printing can be defined with a various set of students, not only mechanical, not only electrical, everybody can come part into the 3D printing part where they can involve and where they can get a good job opportunity, career, they can develop their career into the site. So design for additive manufacturing, which is a core segment of a mechanical site, where you will be learning of how designing for additive manufacturing, like how to reduce the weight of a part, how to do the optimization of the design, which will be a more of a DFM based design for additive manufacturing. This is the core part for the mechanical, whereas into services in AM, which is the services in additive manufacturing, career aspect, a student can open, you can open as like a startup thing where you can create job, you can put up as like a service bureau with 3D printer where you will be having certain edges 3D printers and you will be providing services to the industry. And you will be providing various kind of industry problem solution. You will be creating that to the industries for that. Innovation in additive, you can come up with a very new innovation, like as already we have discussed, like IIT Madras, one of startup has came up with the house 3D printing, which is a concrete 3D printer. Certain level of innovations can be come up from your end, which can not only create a history and you can even develop business and you can develop the workmanship from that. Programming for AM. So for developing of an AM, we need a huge level of software support, which is completely like AI based and even with a complete algorithm and the coding base, which our computer science students and even a different set of students can be more involved for that, where they can do the programming, where they can do the set of software development, and they can come up with a creative software where like different parameters can be set it out, or different technologies can be come out, or different settings can be done in a single go. And therefore comes up with again as a training on AM. You can start up your training institutes or training again like as a college where you will be doing the diploma or you will be doing the engineering on 3D printing. And then after the industries in AM, now already as per the Indian government law, they are now pushing the industries for the full-fledged production to be run out into a 3D printing, where there will be thousands and 2000s of 3D printers, and they will be printing the jobs in a regular go on as like in the regular go. So that is what we will be covering up into our coming up slides, like how 3D printing, what are the applications, and what will be the things. If anybody has any questions, you can directly ask up here. So we will now move to the things now, what the core segment of our day-to-day seminar, where it will be into the what is 3D printing, how it is evolving, and what is going on. 3D printing. So what is 3D printing? So do anybody know how like 3D printing works, or anybody having any idea of 3D printing? Anyone?
I think the participants are muted at the moment.
Okay.
Dr. Das, can you please?
I unmute them all. They can unmute themselves.
Okay, so students can unmute themselves. If they have any query, they can directly interact with the speaker.
So, in 3D printing is actually a kind of additive manufacturing where we can either go layer by layer, like depositing the material layer by layer to create the model that we want to make. It also helps make sure that the wastage of the resources that we're using into making a product, that is lessened by this method.
Yeah, you're absolutely right. Good. So 3D printing, what is 3D printing? Like we will discuss under the 3D printing, what is known as 3D printing and how. So 3D printing is a very common name which has been given. So 3D printing is known in a manufacturing term as an additive manufacturing. So additive manufacturing is the manufacturing terminology, but as a commonly known, which is known as 3D printing. So 3D printing is a process where we will having a CAD file, which has been by using any kind of CAD software like AutoCAD or SolidWorks, Creo, CATIA, any kind of 3D designing software we use, and we can design any sort of thing, any design. It can be like from a very basic cube to a design which can be like a house. So that will be onto our design segment. So once we are doing a CAD file where we will be having using a various category of software, that CAD file has been sliced into a number of layers. This means, sorry. Yeah. So CAD file has been sliced. It's been cut into a number of layers, which is like around maybe 100, 200, 500, as per the geometry, as per the dimension of the CAD file. It's been cut into 100, 200, 500 of a certain number of layers. That each layer has been now deposited by the machine. It's been deposited by different technologies, things, layer by layer of deposition. So one layer got stick, another layer, another third layer, fourth layer, fifth layer, like this kind of thing. Stage by stage layer comes up, which by adding of all the layers, the same we will get the product, which is with a CAD file. So just take an example. You all have seen this our normal 2D printers, like normal our HP printer and all, which print into color. So while our input is like a, what we put into the as an input there. We put input as a word file. Maybe we have written something as a document or something, A, B, C, D or something as an input. We put into the machine. Machine prints into a color as per as our color code, or as per as maybe it is a black and white print or something. Machine deposited a layer of ink, right? Machine deposited a layer of ink on a paper. So that layer of ink is a very fine layer of ink is deposited. Just imagine continuation deposit of that same layer. If we have printed A or B or C, any kind of letter, just imagine we are depositing a certain layer of ink continuously. 1 layer, 2 layer, 3 layer, 4 layer. At a certain deposition level, maybe after 100 layer of deposition, it will get a thickness. It will it's a genuine thing, it will get a thickness. So that thickness we can touch and we can feel it. We can touch the things, we can remove the part, that kind of thickness will be there, that will be a hardy substance. So that time, whenever you are getting something into a like a Z direction or like into the thickness part, that comes into the 3D. So here also, like we will design something into a CAD software, we'll put into the machine will cut that software into a multiple layers, maybe 100, 200, 500 layers. Now machine will deposit each layer, 1 layer, 2 layer, 3 layer, 4 layers, layer by layer deposition, and your product will be formed, where it will be a complete segment of from a CAD file to a original file. Segmentation, like as I told, there will be a certain level of slicing. We will cut the product. Just we take in a simple example, a potato or a cucumber. We cut it, we do the slicing of a potato, we cut it into 5 or 10 pieces for our daily to daily uses. So just imagine after cutting the potato into 10 parts or 20 parts, you again join the same part. You will get that at the same shape of a potato, or you will get the same shape of a cucumber. If we cut the cucumber into 10 pieces in a slicing form in vertical direction, and then after joining all the 10 pieces, you will get again the same cucumber, which will be again the same height or the same dimension, what will be there. So same thing is like something, you design something, you cut the model. Cutting has been done by the software segment. We don't do it by manually. Cutting is done by the software, which is a slicing part. Then after, with the various parameters of the machine, then after it go to the machine, and the machine deposited layer by layer. Obviously, all the layers will be into a equal height, equal thickness, equal dimension things, and it will print layer by layer. Addition of that layer by layer will make the 3D printing product. Just check out with this video how a 3D printing works. That's come our layer, that's come our nozzle. Now nozzle is depositing a layer of just one layer, which is a blue color material. Now it is filling up that layer. So have you checked the video, like how it is printing? So one layer, second layer, third layer, there will be maybe 100 layers of the model, and the model is formed. So this is how the 3D printing works. By any kind of 3D printer, there will be a multiple technology of 3D printing. We will be discussing in the coming up slide, like how many technologies of 3D printing are there, what kind of 3D printers are there. But the fundamental principle of every 3D printer is it will deposit material layer by layer. Maybe the deposition techniques can be differ from each 3D printer to another 3D printer. The deposition technique will be somewhere there will be a raw plastic, somewhere there will be a powder form of plastic, somewhere there will be ceramic. So, but the deposition, maybe the process is different, maybe the technology is different, but the fundamental of 3D printing will be every time the layer by layer addition will be there. So this is one of the video in our machine which we have been printing. So this is a real like a video that that was an animation part where we will be now playing the real kind of video what our printer was printing up. You can see, check directly. So have you seen this? So this is the white part, which is the part which we required. That is a main major part which has been printing up. So there is another part which is the brown part. We will discuss how what is this in the coming up slide. This is a term you just remember. This is the known as support part for printing. We will discuss onto the coming up slide like what is support and how it has been important in 3D printing. So these are the part which has been directly printed for customers and we can directly use it. And this is how the machine works layer by layer. There will be a 2 nozzles, separate degree of 2 nozzles, and it will be printing layer by layer of additions. So we'll discuss now into subtractive manufacturing. Anybody with subtractive manufacturing? What is subtractive manufacturing? Anyone? Subtractive manufacturing? Any idea?
Conventional manufacturing techniques like means milling, drilling. You take a material and then subtract some material to have what you need.
Our desired product, right?
Yeah.
So yes. So subtractive manufacturing is the conventional manufacturing process what we usually carried out in mechanical engineering or in the basic level of engineering. So where a certain level of machines are there like lathe, milling, drilling, shaper, then grinding, a certain different categories of machine are there. So each of us, we take a raw block of material where it like the desired product is maybe something into cylindrical. We take a raw block of material of same dimension bigger than that. Then we cut the product and we get the desired shape what we required. We cut certain level of product and we get a desired shape of thing. So this is what we do in our general practice of our engineering. We have the different segments of machine in our labs and we cut the material. We use different kinds of cutting tools, different kinds of shaping tools and all, milling tools and drill and everything, where we cut the material and we get the desired product. This is the subtractive manufacturing. So there are various ways of subtractive manufacturing. There are varieties of machine where you will be having a milling, turning, grinding, shaper, then after with a high-end control like computer numeric control based CNC based machine. So there will be a set of machine for this, but the principle for all the machine comes the same, where they will cut a raw block of material and they will get to the desired product. Maybe the working principle will be different for other and other, but the fundamental principle will be cutting the material and getting the desired product. So this is what we do in subtractive manufacturing. Yes. So we have seen like the different segment of manufacturing where a set of people are using turning or lathe machine with CNC control. Some are using water jet, but the desired product is like we will be cutting it into a certain level of medium, and we are putting into the part, and we will be developing the product from the same by cutting a certain level of material. What comes up with the additive manufacturing? Additive manufacturing, as we discussed, it's a process where we put up the material, we put up the raw material into the machine, and it prints up layer by layer of material by different, maybe it can be 100, 200, 300 level of layers. So the difference comes up between the subtractive and the additive manufacturing. Why people will use subtractive manufacturing? Why people will use additive manufacturing? Anybody can put on any certain difference? Like what is additive? Biggest difference with additive and subtractive? Anyone?
So in subtractive manufacturing, we have a block of material and then we remove the material from places where we don't need it to bring it in the
Right.
desired form and shape. And in
Right.
additive manufacturing, we start with adding material little by little to create
Okay.
the shape in which we need the material, need the
Okay.
final product.
Right. So this is the principal difference between the additive and the subtractive manufacturing. So with the additive and subtractive manufacturing, how like you have explained it into the perfectly on the right way. So with subtractive manufacturing, remove material by physical or chemical process, where that can be a different segment of process are there: milling, turning, grinding, water jet, sawing. So level of process are there. So this is my desired product. So this was in my desired product. This is a raw block of material. We cut this much of portion and we get the desired product. Where with additive manufacturing, this is the raw material into, maybe it can be into a granule form, it can be into a powder form, it can be into a wire form of material. The raw block of material will be here and it will be deposited layer by layer and we will form the same product. So the layer by layer deposition, the process can be with different where it can be a wire extrusion, it can be powder bed extrusion, it can be some different deposition technologies. So this will be the major difference into the subtractive with the additive manufacturing. Whereas the subtractive with additive manufacturing, there's another, we can't say advantages. It's like the, what are the core advantages? Why we will use subtractive? Why we will use additive manufacturing? Where in subtractive, we see there is a raw block of material. We cut the material with different form. We are doing a drilling segment. We are doing a drilling operation here. Then my desired product is this much. By getting the desired product, this, we usually in subtractive manufacturing, the wastage comes around 50 to 60% of the wastage is there, which is in form of a chips, or which we cut the material, the raw cutting part, it get wastage up. So 50 to 60% is the wastage to get the desired product. Whereas with additive manufacturing, the wastage is about 1 to 2% or even maximum to 5% of wastage. So that's the biggest advantage of additive manufacturing, where your wastage comes down to like a negligible part. If you're doing a production series, your wastage will be into a negligible segment, where with subtractive manufacturing, your wastage lies around 50 to 60%, but your wastage will be here at to 1 to 5%. So obviously where there is a less wastage, you can assume my part will be printed quickly, my part can be developed easily. And the biggest factor which comes down, the cost. The cost of the product will come down. If there is a certain level of wastage, obviously wastage is also a biggest cost which we need to add on to the segment on the market when we are putting into the market. But yes, with 3D printing, if there is a very less wastage, my cost will come down to 45 to 50%, which will be a comparative ratio. What is the wastage is coming. So that is the biggest now advantages of additive with subtractive manufacturing. So now industries are adapting 3D printing for their day-to-day life production, day-to-day life prototyping, or day-to-day life developing of the concept models. So we'll discuss on how 3D printing materials are working out. What kind of materials are, sorry?
Sir, I have one doubt.
Yeah.
Means for additive manufacturing,
Yeah.
If you are making some design, it will take so much time as compared to in subtractive material. If we are making some bigger things,
Okay.
so I think something will cost, like waste material is best for us, but for bigger designs, the subtractive is more beneficial in the sense of the time. Just this is my doubt, sir.
I would like to add one point here that the time factor is very subjective. Like it would
Yes.
highly depend upon what we are making.
True.
A model which is very detailed might be, even if it is big, might be easier to make through additive manufacturing. And if it is simpler, like we just need some round edges at places, then it would be easier to do that using subtractive manufacturing.
Right.
So
Right.
that is
Great.
very subjective.
Subjective. So for developing any product with additive and subtractive manufacturing, so the biggest factor which will come up, like what is the application of the product or what is the use of the product. If I am taking a simple example, a cube, everybody knows a cube, okay? Is it okay?
Yes, sir,
You
yes.
can reply something, yes, no, something.
Yes, sir, yes, sir, yes.
Yeah, cube, you know. So let assume a 20 by 20 or 30 by 30 mm cube, right? All the sides are 30 mm. So it's a very small and a very simple structure. So my any kind of machine which like milling or milling is a perfect machine for shaping a cube. You will shape the cube within a some maybe within half an hour maximum. You can shape a cube into a 20 by 20 form, right? तुम कर लोगे इससे? But whenever
yes,
it
sir,
comes, but now the application or the subject matter comes down. Now you want to reduce a weight or something into the with 3D printing. With 3D printing, you can control a lot of parameters which are like an infill part. You can make the infill surface also hollow with 3D printer. As compared with the subtractive manufacturing, you can't do in subtractive manufacturing infill structure as a hollow. Where with 3D printing, I can do. We can do a things where the infill structure will be a certain maybe 50% of infill. My 50% is hollow, 50% is solid inside. So that kind of things will come up where that is a very subjective way. But yes, if you are doing something, a very simple product, which is a day-to-day life uses based product, very simple in structure, subtractive, you can go very easily in a half an hour of time. But yes, when you are looking for something alternative, but in a different segment of way where it will be having a certain different infill ratio, or where there will be a complex geometry, maybe there will be certain hinges outside, maybe there will be certain geometry which is very difficult to make in subtractive manufacturing. That time the 3D printing is the right way for making the products. 3D printing is never a way, has still now is coming up for a batch prototyping or batch production, where your production level is 10,000, 1,000. 3D printing is okay for that. But whenever your production level goes to lakh of pieces, maybe 2 lakh, 3 lakh, 5 lakh, 10 lakh pieces, 3D printing will not help you. It will not be a cost-effective solution. 3D printing will always be like into your traditional manufacturing, like making of mold, making of your press tools. That will be the traditional manufacturing which will come up. So we'll discuss. We will having the different part.
Okay, sir. Okay.
3D printer in terms of subtractive manufacturing. We'll discuss in the coming stages. Okay. So now comes with the
okay, sir. Clear now.
Material. Yeah, 3D printing material. So there are very basic kind of thermoplastics are available for 3D printing. But with 3D printing nowadays, we can print from basic thermoplastic to composite to carbon fiber, then after with metal, ceramic. So varieties range of thermoplastics and varieties range of composite, varieties range of your metal printing, varieties range of even at the end of the time, you can say a mixture of a concrete also we can print, which is a used for house printing or for a construction equipments. So 3D printing comes up with a very light based product in material terms, and all the 3D printing materials are like the real kind of material, which are the industrial state of material, like ABS or your basic nylon or your basic polycarbonate. These all can be directly 3D printed. So here are a certain range of 3D printing materials. This can be directly, you can get it with any kind of statistics website, where ABS, then kind of flexible material, that kind of a PLA material. PLA is one of the material which is again a biodegradable material, which is a only biodegradable material, polylactic acid, and other materials are not biodegradable. They are all with the thermoplastic sets, and they are obviously they will not be a biodegradable part, but PLA is the polylactic acid, which is a biodegradable material, only material. Then after there are PETG, nylon, carbon fiber, ASA, polycarbonate, a certain huge range of materials are there with for different purpose of applications. Obviously, I will use ABS where my product need a certain strength and certain degree of freedom or flexibility and all, where ABS is a suitable one, and our ABS suits. ABS is one of the most common use material in 3D printing, the most common use, because ABS gives you a good finish, good strength. No, I can't say good, but it's the optimum one, where it will be not a less, well, it will not a very high, but it's the optimum strength ABS can provide, and your basic level of prototyping or basic level of functioning can be done with ABS. Then after there is a varieties degree of material which will come up with nylon, then after with polycarbonate, which are the real life uses material, even with PP, even with PETG, different segments of material will come, where every material has a certain level of temperature coefficient and certain level of density, certain level of your flexibility, and even everybody has a certain level of strength factors. So we will use our material according to our application side. What is my real life use? What is the load bearing capacity? After getting the final part idea, we will print our material. We will choose our material accordingly. This is some of the material which I have found out, which is a very most used and very keen to be known to everybody. Like some materials, as I told, ABS, ASA, and polycarbonate, these are the most common use, in which ABS is the most one. ABS stands for acrylonitrile butadiene styrene. So this is the complete full form of a ABS. ASA is also the same as like the ABS properties and same, although the mechanical properties are very much same. ASA is a very good material which stand for UV protection. Like if your part has to be kept into open sunlight, or if your part has to go with a UV light curing or some part. So ASA has a very good properties which can withstand that UV light temperature or UV after putting any part outside of the market, and maybe it's in a day-to-day life, your open sunlight will be putting up. So ASA is one of the material. Then after comes with the polycarbonate. Polycarbonate is certain material, like PC is the material polycarbonate, which is used for very hardy part, or very kind of a very rigid part where there is a certain level of strength is required. After my presentation is over, I will start my video and I will show you the part which has been printed in our COE. I have the part with me, but both the things cannot be worked together. Like video has been not starting up when we're doing the presentation, so we'll do it on the later side. Just ping me for that, okay? Anybody just remember this and just ping me after the presentation. So I will show you a lot of parts which has been there in our COE. Then after comes with the material known as TPU, tetrapolyurethane. Polyurethane is a very common material which has been used in industries for flexible category of material. So with tetrapolyurethane, we can print directly this kind of flexible parts. Then comes with a nylon 12 carbon fiber, which is a nylon 12 series, and it's a mixture of carbon fiber also. Nylon 12 mixed up with carbon fiber gives us a part which are like excellent in properties. You can see the bike is completely standing on that part which has been printed. It's like a bike stand, and the complete bike weight is on that part. So that part can be directly, it is taking the entire load of the bike. So a bike is around 100 to 150 kgs of the bikes are easily available. So it can withstand that kind of pressure, it can withstand that kind of load. So nylon carbon fiber is one of the material which has been used for very high strength purposes or very high utility based purposes, where it has been used for as a functional part. Then comes, there are three different categories of material which are a very special purpose material, in which one is Ultem 9085, which is a polyamide polyetheramide based material. It is a FFA approved. FFA is an foreign based aggregate approval, where these parts can be directly used in your automotives. It can be directly used in aerospace. It can be directly used in railway. So these materials are railway, aerospace, and automotive certified materials. So they have been tested for automotive, they have been tested for railways, they have been tested for aerospace. Now you can directly use this part in aeroplanes. So we will be sharing some case studies accordingly where they have been used in the coming up slide. So Ultem 9085 is very unique properties of material, where the tensile strength and the torsion strength and the fire resistive property. It comes directly with the FFA certified material, as I discussed, like with the flight parts. It can be directly printed and you can put into the flight, where people can be using day-to-day life, and it can give you that much of certain level of strength. Even with Ultem 9085, it can give you a strength which is like aluminum 7075 grade. It's almost equivalent to the same grade. So with a lighter weight and with the same grade of strength providing with aluminum 7075. So that kind of material is this. This is a very niche category of material. Another material is Ultim 1010. 1010 is again a FFA approved, but it is also FDA approved also. This is something into a biocompatible material which can be directly put up into a human body also for a certain level of time, not for like a complete like 1 month, 2 months, but for 24 hours after sterilization. After doing the sterilization of this part, you can put this part into human body for certain level of surgeries or certain level of as in like a surgical guides or like a surgical tools, or even this part can be also directly used into your aerospace, railways, and even with automotive. This is again a FFA approved material also. And same with Antero. Antero is a PEG based material. It's like polyether ketone based material, which again provide a very excellent mechanical properties, and it has a very good heat resistive properties too. So we will now move into any question till now. Anyone? Any questions with material segment?
Sir, I had one doubt.
Yeah. Can you be a bit louder? Yeah.
Yes, sir. Sir, I'm audible?
Yeah, you're audible.
Sir, all these examples we saw just now, they were polymer based.
Yeah.
So, sir, I wanted to know, is there possibility for metal based or alloy based 3D printing?
True. Yeah, there are materials which are metal based. Like till now, we can directly print titanium, we can print stainless steel, we can print aluminium, we can print copper, and we can print inconel. So certain degree of material we can directly print with metal printers too. But not all certain of materials, not all certain of alloys. But yes, chromium cobalt we can print, like more uses of for dental cases we use chromium cobalt, so that can be directly printed in metal printer. So there are certain material which are, there is a limitation with metal printing till now, but yes, there are around 10 to 12 materials which we can directly print.
Okay, sir, got it, sir.
Sir,
Sorry.
sir, what is minimum dimension that can be printed using this technology?
Your volume is very low.
Sir, my query is what is minimum dimension that can be printed using this technology?
With 3D printing, you are saying?
Yes, sir.
So with 3D printing, we can minimum dimensions like your shirt button, that kind of small thing, around 3 to 4 mm of something. We can print 4 to 5 mm part, a smaller part. And if you are asking me something about the thickness, the small, the finest thickness part which we can print, it is around 1 mm. 1 mm part we can print. Thickness, I am saying, not in the complete dimension. If you are saying about a complete dimension, I will go around say 5 mm.
Okay, thank you.
Got it?
Yes, sir. Yes, sir.
Okay. So we'll continue with the 3D. Sorry. We'll continue with the 3D printing technology. What we offer in our COE. Then after we will again do a brief introduction of the 3D printing. What different technologies are available in the market. So first will be the fused deposition modeling, which is polymer based again, which is the one known of the technology, and this is the first technology to be invented with fused deposition modeling in 1986. They have invented with Stratasys has invented the technology. So fused deposition modeling is something where we used a certain thermoplastic based material. All are for some certain level of thermoplastics where it can get melted at a certain temperature of degree of temperature. So fused deposition modeling, by this name fused, what you are getting by the name by fused? Fused means we are putting some external energy as like a form of a heat. So there will be a raw material which will be into a wire form of structure. You can see in this bottom picture. So this wire is the raw material, which is the main our filament. Basically, it will be into a filament based structure. It will feed it into the machine, and a machine will put an external heat as a fuse thing, external heated thing as an external source of energy to that. So the solid raw wire, now it will get started melting. It will not come into a complete liquid stage, but it will come certain at a level of certain at a viscous stage where it can flow. Viscous means we can say something like as like our jelly, or something as like our a very thick like paint or something, which is that has a certain level of viscosity. So that kind of stage it will come. It will not melt the material. The heat which will be provided to that, it will not melt the material, but it will come up into a viscous state, and that viscous state will be deposition. Like as we discussed, that viscous liquid or that viscous state of material will be deposited at your certain design frame, where your design will be at a certain level of your design, as like maybe it can be cube, it can be a cylindrical part. It will deposit the material and it will be molding. So molding means on the part of the modeling part, where fused deposition modeling will completely placed into the segment where fused external heat is provided. Then the deposition comes up and the model will be formed. The layer by layer of deposition will go on and the model will be formed into the part. So there will be a certain level of, as we have seen the video earlier, we have seen a video where it is printed layer by layer of material. So that is something into the fused deposition modeling. So this is one of the oldest and a worldwide very well-known accepted technology of 3D printing, because that comes up with a very low cost, and even with a very certain level of time, we can directly print our products and we can develop the products. So these are certain parts which has been already been developed and already been used in the industry. This is something under the automotive manifolds, which can be directly put in up. These are the something automotive hose pipes. These are the part of aerospace. Some different infill density with the honeycomb structures. We can directly print up with FDM. So fused deposition modeling is one of the well-known and established technology, which has been more commonly used in the worldwide. So I'll show you a video for that. Everybody can see this na video?
Yes, sir.
So FDM is one of the part where you can understand like FDM printing with the different part of printing, where FDM can be used into the aerospace, into railways, into your automotive, in different segment we can use. So this is one of the technology which our center of excellence offer. We have a state-of-art machine from Stratasys, which are like the world leading company in FDM, and they are the founder of the FDM technology. They have the patent for that. Next comes up with Polyjet. So Polyjet is again a very unique technology which offers you a printing range with a multi-color and even with multi-material also. So Polyjet is again a very unique range of material printing, where it prints up at a certain different segment of color with CYMK combination, as we use in our normal printers, CYMK combination, but with a different range of material also. So it has the working principle of Polyjet is it has multiple nozzles. It print with multiple nozzles, where the nozzles lies from a number of 4,000 to 5,000 jets. It's a very small nozzles, or you can say jets are there, in which Polyjet prints. It deposited material at your required geometry with the jets and with the desired color. So Polyjet is more used for your color based applications or for your aesthetic purpose applications where the end use part can be directly done with Polyjet and it can be shown to the customer, or it can be shown to your any for the brand approvals, or it can be used for your marketing purposes. So Polyjet is a material which is used for final iteration of the model or for your different color segment. And yes, Polyjet has a major playing of a thing with the medical industry also. So as coming up with the medical applications, we'll discuss how Polyjet is useful in medical, and with different machine segment, we'll show you the different uses of the machine. So any questions for FDM and Polyjet printing? Yes, with Polyjet, they use a resin category of material. Okay, Polyjet deposited resin. There is not a certain level of heat is not given. Polyjet is always a resin category of material. It's a liquid-based material. Polyjet takes liquid material into it. It jets. It fire the liquid material through the jets, and it deposited into the machine. So Polyjet also use the for curing purpose. Now you can one thing, you just have a question on the part. If there is a liquid, how it will get solid? Because we need a solid part, right? For 3D printing, we can feel it, we can touch it. Once a liquid is deposited, there is a UV light. These all liquids are photochromatic liquid. So once it comes into the contact of a light, it will get hard, it will get solidified. So this all liquids, once the liquid is deposited, there is a UV lights are there in the machine. Once the UV light fires up, the liquid will get solidified. So you will get the solid part as well. So each layer of liquid deposition, the light comes up and the liquid it gets solidified. Each layer of deposition, light comes and the model gets solidified. So by that process, we will get the part. So I'll show you a Polyjet video. See how Polyjet prints. Sorry, there is some issue with the video. Just I will play it again. Yes. So with Polyjet, as you have seen, there are like multi-color can be printed, shore hardness can be printed, means multi-material can be printed. Like Polyjet has a very unique capability. If you take an example for like something as like an AC remote or your TV remote, so your buttons are into rubber and your remote body is into a hard casing, right? So that can be directly printed with Polyjet. Polyjet has a very unique capability of printing the things into a single go. You don't need to print a rubber material separately. You don't need to print the hard material separately later or doing the assembly segment, but you can directly print with Polyjet in a single go. All the entire functions, all the entire rubber, all the entire complete hard body, even the numberings on the rubber, like the texture, it has been written 1, 2, 3, 4. A lot of texturing has been done into the rubber part, where there is a mute button, where there is maybe a menu button, there is something, a different categories of buttons with the different numberings, with a different texture. So Polyjet can print directly entirely things with the texture also. So that is a very unique and a very capabilities which we are also offering in our Center of Excellence. And Polyjet is a technology which belongs to a company known as Object, which is in Russia, which is an Israel-based company, and now it's a part of Stratasys. So we'll move forward. So there are some now terminologies in 3D printing, a very common terms which we used in 3D printing and which are very important also. So first terminology is infill patterns. As there was a question earlier, so like if we want to print something in normal machining and if we want to do something into our 3D printing takes a long time. So as I have answered that time, like there is some certain level of subject things, but comes of what is the application and what is the uses you are going to do with the 3D printing. So infill pattern is one of the biggest advantages with 3D printing, which any another manufacturing technology doesn't provide. Infill comes up with many sizes, many shapes, which like a different categories of style, which has its own limitations and own advantages also. Infill is something which helps up your part to make lighter in weight. It doesn't compromise the strength also. So infill is a very important segment of 3D printing. So whenever we are doing a printing into our machine, we have the control, we can set the parameters, something like that. My inside body will be at a certain level of infill density, where I can save material, where I can utilize my material time, where I can save some time, and my product will be developed with a very lighter in weight. So this will again depend on the applications. Yes, if there is something part which is a functional part, अगर मैं कोई कुछ बना रहा हूँ जो कि as a functional part use होने वाला है, everybody is comfortable with Hindi English, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Hindi also we are comfortable.
Yeah, that's fine. चलो तो समथिंग अभी हम लोग कुछ बना रहे हैं जिसमें मान लो हमें बहुत ज्यादा स्ट्रेंथ की जरूरत है. ऑब्वियसली मैं उसके अंदर इनफिल नहीं डालूंगा, तब मैं मान लीजिए मॉडल को सॉलिड प्रिंट कर रहा हूँ. बट अभी वैसे ही मैं कुछ बना रहा हूँ जो कि सिर्फ मुझे मैं भी शायद उसका डायमेंशन चेक करना है. मैंने एक डिजाइन बनाया है, उसका मुझे डायमेंशन चेक करना है, उसका मुझे फिटमेंट चेक करना है, वो एक पार्ट के अंदर असेंबली हो रहा है कि नहीं. दीज आर नोन एज फिट एंड फॉर्म टेस्टिंग. फिट एंड फॉर्म टेस्ट के लिए तो मेरे को सॉलिड बनाने की कोई जरूरत नहीं है. तब मैं क्या कर सकता हूँ, उस मटेरियल को मैं सेव कर सकता हूँ, मेरा टाइम सेव होगा, मेरा मटेरियल सेव होगा, ऑब्वियसली मेरा कॉस्ट भी कम आएगा. सो इन टर्म्स ऑफ लाइक किसी चीज का प्रोटोटाइपिंग बनाना, किसी चीज का जस्ट डायमेंशनल चेक करना है, तब हम लोग इनफिल डेंसिटीज को ज्यादातर यूज करते हैं. वी कैन मेक दैट पार्ट एट सर्टेन लेवल ऑफ मे बी 20% सॉलिड और 80% हॉलो. दैट विल अगेन एप्लीकेशन. अभी मेरा कोई फिटमेंट है जिसके अंदर मुझे शायद थोड़ा प्रेशर लगेगा, थोड़ा प्रेशर के साथ मुझे डालना है, तब मैं शायद उसको 50-50 रेशियो में कर लूं ताकि उसका स्ट्रेंथ भी एक ऑप्टिमम स्ट्रेंथ भी रह जाए प्लस वो मेरा काम भी हो जाए. सो दैट इज द एडवांटेजेस कम्स अप विद 3D प्रिंटिंग. कोई भी टेक्नोलॉजी ऑफ मैन्युफैक्चरिंग विल नॉट गिव यू दिस फैसिलिटी व्हाट 3D प्रिंटिंग कैन गिव. सो देयर आर नंबर ऑफ इनफिल रेशियोज, हेक्सागन है, लाइंस है, स्क्वायर है, फिर हनीकॉम है. सो डिफरेंट इनफिल पैटर्न्स है, so which we will use as per the different applications of our products. ठीक है? Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
So this is one of the biggest advantages with 3D printing, जहाँ पे हम लोग infill patterns को use कर सकते हैं as to reduce the time, reduce the weight of the product, and obviously it will be not seen from the outside. इसको हमें बाहर से पता नहीं चलेगा, बाहर से वो दिखेगा हमें solid model है, बट शायद उसके अंदर का जो थिकनेस है उसमें हमने इस तरीके के पैटर्न्स को पुट किए हैं. सो फ्रॉम आउटसाइड इट विल बी अ कंप्लीट नॉर्मल मॉडल, बट फ्रॉम इनसाइड दैट कैन बी सर्टेन लेवल ऑफ हॉलो विल बी देयर. इज इट ओके?
Yes, sir.
So we'll come up with another topic which is support structure. So 3D printing, yes, there is a wastage in 3D printing too. 3D printing में भी एक wastage आता है, जैसे मैंने बताया था 1 से 5% तक का एक wastage आता है. Now you just imagine there is a product, support. We need to develop certain level of support structures when we are doing 3D printing. So 3D printing में support is not the part of the model. जो model हमारा desired model है, support structures are not the part of that. So we need to develop that support structure additionally, which is considered to be the wastage of the product.
Sorry for interruption. Mr. Bhattacharya here.
Yeah.
Can I please just be excused, please? Can you please continue in English, because there are some students maybe they do not understand Hindi.
Sorry?
So there may be some students who do not understand Hindi. So maybe is it okay to continue in English?
Yeah. That's fine, sir. No issue. Yeah, that's fine.
Sorry for.
Yeah. So support structures are the part of the model, are not a part of the model basically, That is an additional thing which we use to develop the model. So support structure is always considered as the wastage of the model. So it's our responsibility when doing the 3D printing to orient or to structure the part in such a way so there is a less to less minimal support development. So the support development will be as less as our part will be, as the wastage will be less. So why we need support? Something, if imagine like this kind of structure as like a Y. You can see this, everybody, Y. So in this structure, this Y part, this part, and this part is a overhanging part. So there are something which doesn't have any base. If there is no base, material cannot be deposited into the air, right? We can't deposit the material into the air. We need a certain level of base to deposit the material. So that if there is no base in an overhanging structure, so that time there is an artificial base will be developed, which is known as a support structure. Let for example, if you are doing a 3D printing, it's a layer by layer technology, right everybody? So my
Yes,
Y is like in a, yes, my Y is into a standing position, like into a vertical position, how it is now here. Okay. You're seeing the Y? Huh?
Yes,
so
sir.
this part has a base. This is the bottom part, which has a base. Material can be deposited up here. Then it will go like this, like this, like this, like this. But at this point, at this corner point, there is no base up here. How the material will deposit the Y here? So it will develop a artificial support from this part and this part. Same case whereas the H is considered. If you see the H, if it is in a standing position, H is into a vertical position. Imagine the H is in a vertical position. Okay. So this is the overhanging part, right? So there is no base here. If it is a Y, so this part will be into a air. This part there will be no base. If same as for the T part, these both the part will having a no base. This will be an overhang part, which will be completely like if it is in a vertical orientation, this will come to that as the overhanging part. So material cannot deposit it here. If they start depositing at this point, this will fall down. So this material, they will develop an artificial support here, artificial support structure. So which will support the bottom, and then after the material will be deposited. So see, if there is something like this kind of structure, if like the Y kind of structure, there will be an artificial support developed here. So this is the support, which is a wastage part. But this is required if you want to print such kind of thing. So this can be eliminated by putting the part in a certain direction or certain ways where there will be a maybe support will not be developed, or maybe a minimal layer of support will be developed. Sorry. So let now comes into the thing where all of you will answer me some of the part. Let consider this Y. How I will orient this Y? Let you consider this Y has a thickness of 10 mm. Okay. The Y has a complete thickness of 10 mm. Okay, everybody?
Yes, sir.
Yeah. So how I will place the Y in a orientation so that there will be a complete base. We don't need to develop support. How I will put it?
Sir, it is simple. Like if it is front view.
Okay,
Hello?
it's a front view. Let Y have
then you
Y
just
has a 10 mm thickness.
Just tilt into just 90 degree. You turn it, and like Y is seen from top view, and just Y shape. So I think there is no need to.
Right. If
like,
you consider Y as from the top view, then it will have a complete base, right?
Yes, sir. Yes, sir.
Yeah. So that time it will not develop any support.
So the two legs of Y will make it a stable structure.
Sorry?
The two legs of Y on the base will make it a stable structure.
No, your volume is your sound is not audible. Can you speak a bit louder?
Yeah, I was saying that the two legs of Y on the base will make the structure a bit more stable.
A bit more stable, right? Yes, as like Mr. Sharma, Dev Sharma, he has been replying up. So he has mentioned, if we consider this Y from the top view, so the complete body will be into the base, right? That time there will be no support development will be there. So let's consider for the H also, how we will orient the H in the top view or in the front view. so that it will develop no supports?
Same as Y.
Same as Y?
Yes, sir.
Yes, sir.
Okay, you tell me for the T now.
For T, it is also same.
Any another view? Tell me, in which there will be no support development.
Sir,
Upright down, sir.
Invert the T.
Upright down. Yes.
reverse the
Upside down.
yes, sir.
Upside down formation will be the best, sir.
All right.
180 degree if you are turning, then no need to do
No need, right? For
addition,
like
sir.
the T will be into the inverted shape, like it will be in the opposite T, like, right?
Yes, sir.
So this kind of thing we have to identify during printing. So we have to set the printing in such a orientation or such a manner so that there will be a less to less support development. So minimum support development, your part will be into a minimum wastage. Obviously, the higher support development, there will be the higher percentage of wastage, right? So this support also play a very vital role. You always need to be very careful when you are doing 3D printing. My orientation of the part should be into a certain way where the support development will be minimum. Otherwise, it will make you a higher cost. The product cost will increase. The material will be consumed. The product cost will increase. Okay, everybody? So these are the two major terminologies which has been used in 3D printing. One is your infill density, another is support structure. I will mention about another one which we will discuss into the verbal form. It is into a layer height. Something into the layer height. Okay. So layer height. Anybody has any idea what do you mean by layer height? What do you understand by this term layer height?
Thickness.
Anyone?
Thickness of the material which is
Sorry?
being deposited. Sir, the thickness of the material which we are depositing.
The thickness or the height of the material, right? The each layer what is depositing. So layer height is also one of the factor in 3D printing. Whenever you are doing a 3D printing, this layer height will also will be one of the factor for your surface quality or for your time duration. So layer height will play a very major role. Whenever you are printing in a 3D printer, so layer height can be controlled from 100 micron to 300 micron. You can put any kind of layer height from 100 micron to 300 micron. So if, let for example, my height of the object is 20 mm. My height of the object is 20 mm. My each layer which will be deposited, the each layer height is 100 micron. How many layer we have to deposit? Anybody? Tell me the answer. My total object height is 20 mm and one layer height is 100 micron. How many layer we need to deposit?
200 layers.
Sorry?
200 layers.
200 layers, right? So whenever we are depositing 200 layers to get the model of 20 mm. So you can understand the layer is very fine, 100 micron. Just on the segment we put my layer height as 200 micron. And how many layer now I have to deposit?
Just half of it.
Half of it. So it will be around 100 layers. So depositing of 100 layers, I am getting a same model of 200 micron, but 220 mm. But the difference will be, obviously with 200 micron layer height, my model will print as faster. At 100 micron layer height, my model will print at a very lower speed. But the quality, my layer, as the finest the layer, your surface quality will be more better. As the thicker your layer, your surface quality, there will be a layer mark you can see later on. If your layer thickness is getting higher and higher, there will be a lower surface quality. And if your layer thickness is layer thickness or layer height is getting lesser, your surface quality will be very smoother. So this is something, one of the another part with 3D printing which we need to consider during printing. So you remember this three technology, three basically term, tell me, which is more important? So one is support, one is infill density, and another is layer height. So using these three parameters, we can change lot of things with the 3D printer. So now we'll come up with 3D printing advantages. How the 3D printing advantages are there? What are the 3D printing advantages in our industry? So first advantage is complex shapes. So you can see this model. Everybody can see this?
Yes, sir.
Yes. So this kind of complex shapes we can directly do with 3D printing in a single go now. We don't need to see, it's not like that earlier it has been not been developed. This has been developed earlier also. This has been developed आगे बेटा होयचे, it's been developed earlier also. पहले भी हुआ ऐसा, maybe होते ही रहेगा. But if you have a requirement, it will be developed. But with 3D printing, it is making more easier for the people to develop this kind of complex geometry. But with earlier, what we have to do, maybe we will be creating some joint up here. Maybe there will be 5-6 different categories of joint will be there. We will be joining the part and we will form this product. But with 3D printing, this joining can be eliminated and we can do it in a single go. So that's the major advantages of 3D printing. So if you see this second example, this is a cube. Inside there is another cube. Inside that another cube. Inside that another cube. Yes, this product has been developed earlier also with normal conventional manufacturing. But how they have developed? Maybe they have developed the cube. Maybe they have kept one face open. They have put the another face from another cube from that face, third face from another face, and they close later on. Each face has been closed, or maybe there will be a certain level of joints. Maybe there will be a certain 20 or 30 joints are there. After joining this all, they have formed this cube, gyrographic cube. But now with 3D printing, you don't need to have a development of the joint. You can directly print in a single go. So this kind of, again, the complex geometry can be done. So 3D printing is making the complexity of the model free. The complexity of the designs are making now free of cost. Like earlier, what was happening, if the model is more complex, your cost is also more. As depend on the complexity of the model, your cost depends. But now the 3D printing is making that cost and the complexity cost is zero. For 3D printer, any kind of complex geometry, it can print. That's the advantages comes. So it also relies on the designer capability. Being a designer earlier, you have to think of the machine capability. You have to think of the how my machine can perform. According to the machine capability, you have to do the design. Yes, let for example, you all are from moreover you are from mechanical first year students or combined batches there, 3 years, third year, fourth year, everybody is here.
Yeah, cross department is also there, sir.
Sorry?
Other departments are also here.
Okay, other departments are also there. So just for an example, if I consider, if there is a cylindrical job, right? My requirement is something as a cylindrical part. Which machine you will choose for manufacturing that? In conventional, tell me.
Lathe machine.
Lathe machine. So just imagine you are having a shaper. Okay, you are having a shaper machine and you have been given with a cylindrical job. Do it will be easier for you, or it is possible for you to do that?
No, sir, not possible.
Not possible. So that's what the comes up is, maybe your requirement is something is a cylindrical job, but your machine what you are having is a shaper. So now you can't do a cylindrical part. So according to your machine capability, now you are changing your job capability. Now you are changing your design format. Maybe you are doing the design in square form or something which can be done by the machine, right? But with 3D printing, as per as your design, 3D printing can print square, 3D printing can print cylindrical, it can print round, any kind of surface. Okay, so that 3D printer can do. So your complexity or your freedom for design will comes up. So you don't need to think of the capability of the machine, or you don't need to think of your what machine can do, and you can directly do a free form of design, free form of complex geometries with 3D printer. So that's the one of the major advantages of 3D printing. As earlier it has been a question, why we will use 3D printer and with the conventional machines? Yes, if there is a complex geometry which are very difficult to do with conventional manufacturing, that time the 3D printing will come into a play. But the same, whereas you required a cube, normal cube, which is maybe a solid cube, you will not print it with 3D printer, because 3D printing is not meant for to doing that. 3D printing is meant for something which is not possible with a basic conventional way, or which you want to do it into a separate segment of way, where you will be doing it into a separate, maybe a cube with a certain level of infill, maybe a cube with certain level of different complex things. So that can be done with 3D printer. So this complex shape is understood by everyone, why 3D printing is being used, right?
Yes, sir.
So next comes with the freedom for design. As we are discussing, now your design freedom is completely with you. You can design freely, like what comes up your mind, you can directly design. That can be combining your a model of a new pair of shoe, a model of a chair, something which has been used, some with a shoe with a phone casing, your USB cover, your toothpick holder, your mobile holder, anything which is not available, a customized solution, you can freely design from your end. You don't need to depend on some of the particular machine or some of the particular degree of machine, and you don't need to limit your designing capability. You can design it completely freely, and you can achieve that product with 3D printer. So you don't need to now rely on the machine. Yes, what my machine will do and what will be the final output, you don't need to think of that. So now you will be available with the entire design freedomness. Customized parts. Whenever there is a customization comes up in manufacturing, the cost will go up, boom up. Let for example, anybody goes into a market and they ask for a customized pair of maybe customized pair of shoe. Do it is available? Is it available in the market?
No, sir.
No. You need to order to them, or you need to tell them your requirement. What is your requirement of your shoe, or what is the requirement of some of the customized part? Then the company develop accordingly to you. So the cost is also very higher because they are developing particularly the dedicated part for you. It's not a standard part. So whenever customization comes, conventional manufacturing can't do it. Conventional kind of manufacturing is not able to do a conventional customization part. Maybe something you require a shoe with a different angle or with a different sole height. You can't do. So that now 3D printing can do. So any kind of customization, you need a separate mobile casing. So you are not getting into the market as far as your desire things. You can directly develop, you can directly do the design, you can directly print it with the 3D printer. You need a prosthetic leg, which is a very unique or very different looks based. So you can directly print up with 3D printer. You can directly use it also, because nowadays a lot of carbon fiber based materials are available which can be directly used as a prosthetic. Can anybody tell me what is this green part? कोई बता सकता है? Anybody can tell me what is this? क्या बोलते बार बेटा की एटा?
Tool.
A flat foot corrector.
Sorry?
It is the base of the shoe, right? It is supposed to shape up according to your leg, like feet.
Feet, yeah, right. According to your feet.
Yeah.
So let for example, let somebody is having maybe 6 or 7 fingers in his feet. Okay. In your leg, you're having 6 to 7 fingers. It's very difficult for a person to wear a normal pair of shoes, right? Is it very easy for him to
No,
wear
sir.
a normal pair of shoe?
Obviously, no, sir, because it is something.
He is like having a maybe he is having something with a 6 or 7 number of fingers. But again, customization a particular shoe for him is a very high cost is involved, right?
Yes,
so
sir.
in that case, this insole can be developed with the certain according to his leg posture, according to his feet posture, where it can be have a 5 or 6 or 7 fingers inside, where his all the fingers can be placed into a certain bracket inside this, and this insole can be put into a normal standard shoes where he can put his finger properly. So with this kind of customized solutions in a very small In Bengali, usually we say like an insole or like what we put, like a black color foam kind of thing we put inside the shoe, right? Everybody, we usually put that. It's like a sponge, like a substance. Insole, basically.
Yes, sir.
So that can be customized with this kind of rubber material of 3D printer according to the need of the person, according to the need of this fleet, according to his flat base or according to his need of the feet. We can directly customize this according to the person. So this can be a very customized solution for the people, those who are having this kind of disabilities or this kind of, even like, I can't say this is a disability. This is like something, a unique problem what they are having. So that can be solved by this kind of thing. Some people with the earbuds also, some people like fleets, this earbuds, everybody has a customization thing. Like a lot of the standard models cannot fit into your ear, right? So that time you can't do a customize from the companies. But with the customization with the 3D printing body or 3D printing things, you can directly do your own customization parts and you can use it also. So customization is again another big segment of 3D printing, where not only these three examples, there will be a number of examples will come up. Maybe being a company, you want to customize someone as a table name or something, you want to customize with different people, or you want to develop a bottle with a customized name, or you want to maybe a cup with a customized name. Okay, so that time you can directly do with 3D printing, which will be again a cost-effective solution for you. So that comes now with the 3D design optimization. So even this is also a case study. When we will be discussing the case study, this case study will be there. So, but this is a very good example of 3D design optimization. So design optimization is the biggest advantage of 3D printer. With 3D printing, we can do this design optimization, which comes down the weight factor, which doesn't compromise the strength also. So do you know this part? What is this? Anybody can tell?
Just a seat belt fastener, sir.
That seat buckle, right?
Yes, sir. Seat buckle.
Yeah.
For aircraft.
For aircrafts, right? So people, those who have gone with the flight or those who have traveled by flight, they have seen this. Okay. So just for a standard ratio, this is the case study with Boeing only. They are using now metal 3D printer for developing this kind of buckle. So these seat buckles have been now developed. So with this standard seat buckle with around 800 to 850 of seat passengers, the bigger flight of Boeing or Airbus, 150 gram is the weight for steel, normal stainless steel. It comes up with a weight of 155 gram. If they develop the same part with aluminium, the weight comes down to 120 gram with aluminium. This is a standard process of development, right? With the standard process, they were developing this at a certain weight of this. But now with design optimization, which is a lattice structure development, this kind of hole, this kind of structure is a lattice structure development, which is a generative design part. This mechanical can be more, they can relate this with their engineering, with their CAD knowledge. Generative designs is one of the topic which is now booming up, which is a design for additive manufacturing. By using DFAM, they have designed this. This is the final output they have came up, where the same strength and where the same mechanical properties are not being compromised. Mechanical properties are same here. The entire mechanical, like stress, strain, everything is same in this model, but the weight of the part with aluminium comes down to 68 gram, 120 to 68 gram. So now you can imagine, like it's a decrease of 52 gram in a one seat buckle. So if you consider there are around 850 seat buckles, each of 52 gram reduction, so there is huge weight reduction in the aerospace. In aerospace, if you can reduce 1 kg of weight also, that is a bigger advantage to them. Their fuel efficiency increases, right? Anybody?
Yes, sir.
Yeah. With the fuel efficiency increasing or with the productivity of the aeroplane increases. So now Boeing will be developing this kind of seat buckles in coming days. You can see it in the flights where they will be using these seat buckles and they will be putting up into the planes for a very high weight reduction. So 52 gram for each seat buckle is now reduced. So this is one of the biggest advantage with 3D printing, the design optimization. With design optimization, we can achieve big things with a very lighter in weights. So now the 3D printing technologies, we have already discussed two of the technologies, which is around FDM and Polyjet, where FDM use wire form of filament and Polyjet use liquid kind of material. Polyjet is material cured by light, and FDM already it's a semi-viscous kind of material which has been flowed and which has been deposited. Till now, any questions? Any questions on material, technology, terminology, and with the advantages of 3D printing? Any questions till now?
Sir, I have a question.
Yeah. What's your name, please?
Sir, my name is Shoham Chaudhary.
Shoham. Yeah, tell me. Shoham.
Sir, so compared to a solid object, when you are 3D printing an object, there are layer by layer of material. So is it the case that between those layers that they will act as a point of weakness?
Yes, true. In some of the part, whenever you are printing maybe an object, layer by layer are deposited. Layers are deposited into a vertical orientation, which is the Z direction, right?
Yeah.
At certain level, this is also a negative point of 3D printing, in particularly in FDM printing, FDM, fused deposition modeling. This layer by layer sticks up, but it only provides a certain level of strength until unless the force is acting parallel to the layer direction. If your layer is deposited in a flat direction, okay, and your force is also acting on the same parallel direction, there is a chance that layer by layer will come up. The part will be not a broken, I can say, but the layer by layer will be separated. That can happen. That is also a disadvantage. But to avoid such kind of disadvantage, what we do, we orient the part in such a way, as I told, we need to know the application, we need to know the detail of the part, in which way the force is acting. If my force is acting in X direction, I will always print my layer perpendicular to that, so that the layer should not get out. The layer should not get dismantled. My layer should not get separated due to the force. So whenever the force is acting parallel to the layer, there is a chance you always try to orient the part in such a way the layer direction will be perpendicular to the force acting, right?
Yes, sir. Yes, sir.
Yeah. So this we have to always take care. But this is the disadvantage comes up with only with FDM, because FDM provide only XY dimensional strengthening. But with other kind of technology, what we are going to learn now, the different technologies of another 3D printing, whereas with SLS, whereas with SLA, this provide uniform strength, which is an isotropic strength based property. So in this part, you don't need to worry about all the layer thickness, layer directions. Here you will get isotropic properties, because these are a liquid. Here layer marks will not be there. Whenever there is a layer line marks, that is an FDM part, which has a disadvantage for this. Okay, anything more?
No, sir. Thank you, sir.
Anything more? Anyone? Chalo. Then we will continue with the different printing technologies now. Okay. With different printing technology, we have already learned two technology which are there in our COE. Now the other technology which are worldwide accepted and worldwide available in the market. So first is FDM, fused deposition modeling, where we already have learned like how FDM works. So another technology is SLA or oblique DLP. SLA is selective laser additive technology, where there is a certain level of, this is also used by the liquid form of material, the same liquid material which is a photochromatic liquid, but here the light source is a laser. In our machine, in Polyjet, the light source is UV. Here the light source is a laser. So laser cure the material according to the desired shape, the laser moves according to the desired shape and the material got cured and you get the product. We'll show the different videos for each of the part. I'm just clearing out the topics first. For SLA is this. Then after there is SLS. SLS is another technology where we used selective laser sintering. Here there is a powder form of material which is been sintered by laser. Sinter means it gets fused, the powder gets small, slightly melted, and the next powder get melted and the powder particles get joined easily, by which the product got formed. So these kind of materials, this provide isotropic properties. Here you don't need to worry about the layer. This provide the isotropic properties due to the fusion or due to the sintering position. SLM, selective laser melting, this is the same technology, but SLS is used for thermoplastics, which are more used for polyamide nylon 12 material, and SLM is used for metal. So here the laser power is more, where even the powder granule size is more, where there is a metal powder is there. We sinter the metal powder and the metal powder got joined and we form the product. PJP is the Polyjet technology, which we have already discussed. And there is one more technology, which is the binder jetting technology. Binder jetting is also used for powder material, where there is a powder material is there and the binder agent, there is some of the liquid agent is used, which is a binder, which is like a gum, and it been deposited according to your desired geometry of the design, and it bind the material. It got stuck with the powder material and you form the product. There is a LOM is one other technology. LOM is a lamination based 3D printing, where we use lamination sheets and it cut the lamination sheet and it get printed up with the lamination addition. Clip is a very old form of printing, where it has been now converted into the SLA printing. Clip is one of the oldest technology, but now the advanced technology is SLA, so which is similar to the clip, which is a DLP based technology, where in clip we use direct light processing, which is now the advanced form of clip. In clip, we were using LED. We have been using LED lights. Not only LED, it's a certain level of projector, you can say, where it projects each layer and that projected layer gets solidified. It's a normal projector policy. So we will see each of the video for each of the technology. So first come with SLA. Already we have covered the FDM videos. So this come with the how the SLA printer prints. Yes. So have you seen the technology of printing? So how it is printing the different categories of material? First, it was printing a sun goggle for the industrial goggles, which has been used. When it has been printing industrial goggle, have you seen this part? See, is it visible? Everybody can see this part.
Yes, sir.
So you see the
Yes, sir.
structures inside the model. Are you able to see this line structures?
Yes, sir.
Yes, sir.
So these are the support. So these are the support which will be broken away later on, and this product will be the final product. Okay, you have seen as this. So it has been deposited. This you can see this liquid. So this build tray go inside the liquid. There is a laser in the bottom. Laser moves according to your dimension of the product, and that got solidified and it got printed up. Okay, so this is one of the technology known as SLA, which is the another well-known and well-function based technology. But yes, SLA printers are smaller in size. You can't print a very long based products like very maybe a half meter or 1 meter products. You can't print in SLA because SLA, this liquid is a certain build volume is a limitation for the SLA technology. But yes, SLA technology is again a very fast technology as compared with FDM. SLA is like 100% faster than that, and SLA is a very fast technology. We'll move up to the next technology, which is SLS, Selective Laser Sintering. Here we use powder for our printing, and laser cure that powder by sintering process. Laser comes up and the powder got sintered, and each powder particles got joined each another. So I will show you a video for that. Yes, so everybody has seen the SLS technology, how it is printing. So in a powder form, laser is sintering the material and it is getting the product. So biggest advantage of SLS technology is there is a support development is zero. You don't need to develop support here. Why can anybody tell me why there is support development is zero? Can you please,
Because
after seeing the video?
because the product is going into the powder base, so we are putting the next layer on top of the previous layer.
Right. So,
Yeah,
but
because
there
the
is a hinge portion, right?
yeah, because the powder itself is going to support the product. It is as it is surrounding it from all sides.
Yes. So powder is acting as a support material in case of SLS technology. So powder is always acting as a support material. So it is not taking as a solid form of support, right? As with FDM and SLA technology, there is a solid form of support development is there, right? Where there is a FDM is developing an artificial support, and same as for SLA resin has been developing with the artificial support. But with SLS, being the laser is moving only into the direction where the our real geometry of the part is, but the hinge portion is been taken care by the powder material, where the powder is acting as a support material for the entire body, right? So this is a very advanced technology of SLS, and which is the most technology in which we can do a certain level of manufacturing, a batch manufacturing in a very shorter of time. So SLS is one of the technology which is been invented for batch manufacturing. So it can print a very short batch, like maybe 100, 200, 500, 600 pieces within a very short minimal time, and with a less time also, because there is no support development, there is no post processing time. We can directly take out the part. We can just wash it with any kind of brush or any kind of vacuum based thing, and the powder will be suck out, and you will get the product finally. So we'll move to the next technology of printing, which is SLM, which is used for metal printing. SLM will be the same as like with the SLS. It will be the same technology where we will use same laser, but the laser power will be very high, because now we have to sinter the metal powder. Now we will move on to the binder jet technology, which is another set of technology which use binder as a material and the powder as a raw material. There will be something as a binder, which is an additive material, adhesive like kind of material, which will bind the powder at our desired geometry. We'll play the video for that. Yes. So have you seen the video now? So this is known as the binder jetting process. So binder jetting is one of the process which is more used for a material such as like sand. So sand can also be 3D printed. So this is a printer. These are the printers which have been used for sand printing. So this is more used for a companies, those who are into casting, for like sand casting, or like so some of it into the investment casting. So they use this kind of product where they can develop the patterns and the dyes of the pattern directly with the sand in a very minimal of time. So binder jetting is one of the famous process for sand printing. We'll move to the another process. Sorry, any question? So another technology is a LOM technology, which is again a lamination based technology where we use lamination sheets. Lamination sheets will come into the play. It will come into the base of the machine. There will be a small cutter is involved. A small, very sharp cutter is there. It will cut the lamination sheet, a single sheet, and another layer of lamination sheet will come. Again, it will come cut into the desired shape, and this each layer by layer there will be addition will be there, and it will do the addition. So everybody has seen the Calcutta airport. Calcutta airport, everybody has visited. कोई गया हो? Anybody? जरा गए Calcutta airport है? कोई नहीं हो Calcutta airport कोई नहीं गए? Nobody has visited Calcutta airport.
No, sir.
Huh?
No one from the side?
Anybody who is from Calcutta? Like who has been staying in Calcutta for a long time, they have visited with Calcutta airport, traveling has been there. किसी ने travel किया Calcutta airport से?
Sir, I have visited Calcutta.
None of the students were here.
None of the students. Okay, sir. So in Calcutta airport, if you are in Calcutta airport, please visit the segment to the part to near to the international way where all the restaurants are there. So there one Durga idol is there, a big Durga idol, which is the first 3D printed Durga idol, which has been done by a company, and they were been worship in 2014 to Jodhpur Park. Jodhpur Park, there is a park here in Jodhpur Park. In 2014, this Durga idol was been there, which is the first 3D printed Durga idol. And that has been printed by using this LOM technology. So whenever, sir, any students, if you are in Calcutta airport, if you're going through any outside Calcutta by flight, please visit that place that has been kept inside the Calcutta airport. That is the first Durga idol in India, which has been 3D printed, and the technology was we use is LOM. So we'll show you the video, how it is printing. So this is one of the very old technology known as LOM, but this process is very slow. So nowadays, in terms of very advanced and very high-end technologies of 3D printing, LOM is getting certain level of extension. So LOM will be no longer further used for a grade of 3D printing and technology base. Whereas I told that Durga idol has been printed with LOM technology, it takes around 6 to 7 months for total printing for developing that model. So you can understand like the time is a very high factor for development of in LOM technology. And with LOM now, LOM is not been fully functionally used for 3D printing. But this is one of the very new and very creative technology of printing, which I think like you should know about when we are doing of the 3D printing. So this is a very vital technology, one of the. So now we will focus onto the current manufacturing processes, like how 3D printing is evolving into the current manufacturing processes and how it will helping the industries for developing manufacturing or the manufacturing development. So till now, any questions into technology part, different technology? Any questions?
Sir, the Polyjet technology, sir,
Yeah,
can it be
bit
used for
louder.
the batch
Hello.
production?
Bit
Sir,
louder, please.
Sir, I was asking that the Polyjet technology,
Yes.
can it be used for batch production?
Polyjet can be used, but see, when there is a batch production is going, means a certain level of identical parts you are doing. But batch production, the fastest technology will be SLS. Polyjet can be used in terms if requirement is something like with full color. As I told, Polyjet is used for full color based printing or for the aesthetic part. Maybe you requirement some of the part which is a full color based, where SLS will be not applicable because SLS print into a single color. It can't print into multiple color in a single go. So that time Polyjet will be the perfect solution for batch production. If you require 100, 200, 500 pieces with full color of some model, that time Polyjet will come into the play.
Okay, sir.
Any more questions? Anything more? No one? So we'll move to the now current manufacturing processes. How 3D printing is developing into the current manufacturing process. So first is injection molding. Anybody know about injection molding? किसी को पता है? Anyone? क्यों जाने इधर व्यापार है? Anyone knows injection molding?
No, sir.
So,
Yes, sir.
wax,
Sorry?
sir, actually, it's like a wax pattern. We are making, and after that, from that wax pattern which we make, we give that molten material inside it, and the wax diffuses and the material made.
No. It's not a injection molding. You are talking about something like investment casting, where there is a wax pattern is there. Whenever a term known as pattern comes up, it's a casting. In molding, we don't use patterns. Okay, I will tell. So injection molding is a process for, it's a worldwide, it's the biggest process for high scale production. Okay, where your quantity requirement is in lakh of pieces or in maybe in 2 lakh, 3 lakh pieces. Injection molding is the best suitable way for doing that. Where with injection molding, there is a core and cavity. Like there is a die portion. Like you can see this part. Okay, this part. So this is something a cavity part. This is something a core part. So there is always a male and female part. And there will be a small orifice, a small gap where at a very high pressure, a molten plastic is pushed. Okay, like if you can see this, so this is the raw plastic which is in put in raw block of plastics. Okay, pebble form, granule form plastics has been put. The plastic go inside the hopper. There is a very high temperature is been there where the plastic is melted, completely liquid. Okay, it's been melted into complete liquid form. Then there are plungers are there. Okay, so you can see this kind of round things, plungers. So it pushes the material at a certain pressure in the forward side. So there is now this die comes up. So there is a core part and there is a cavity part, and there is a between, there is a gap. So this gap is your desired product. So this gap is your desired product. So with this orifice, the material goes in, the material start filling up, like this. You can see in this stage, the material start filling up in this stage, okay? And it gets out from this part, from the sixth die. So once it get out, means the material is completely filled, okay? So after opening the core and cavity part, I will get this part. So this is something as like, this is the cavity part, this is the core part, and this black part is my material, is my desired product. So injection molding is the worldwide accepted fast grade production technique where you can do, it's a production tool where we use to develop products in lack of million of pieces. So in injection molding, 3D printing plays a very vital role nowadays. With 3D printer, you can develop the mold, initial mold, because after developing a mold, they go for a trial stage, which a production known as T0 production, trial production, where they develop 30 to 40 to 50 pieces to see the quality of the part. Is it up to the mark, or they do need to do a certain level of modification in the mold? Are my mold are performing in a right way? So that kind of dimensional things they check. So if, for example, you develop a mold with metal, a very high precise, you develop a mold, it costs 10 lakhs, 20 lakhs, 30 lakhs, and even in crore also, like depending on the utility and depending on the mold material. Like if you are developing a mold for an automotive company, a car bumper, so that kind of molds are very big, and you need to have a very highly accurate things. For T0 production, for the trial production, when we will run, if there is any challenges in the mold, maybe some dimensional challenge, that time your production, your mold, you need to again develop it. Maybe at a certain point, your dimension is less. So you can't add material at that time, right? You can't make it more. If in some time your dimension is more, you can cut it and you can decrease it down. But let, for an example, your dimension go down. How will make up it? So there is no way for that, right? So that time people develop 3D printed trial molds for doing the trial. After doing the trial of 40, 50 pieces, once they get satisfied, yes, my mold dimension is completely okay now. This is the perfect dimension for my mold and all the testing is completed. Then they go for the metal mold, which will be used for their lack of pieces. So 3D printing is now coming up as an option for T0 production mold, which is again known as soft tools. Soft tool can be done directly by 3D printing. So injection molding, 3D printing is playing a very vital role on that. 3D printing is coming up with the T0 production grade molding. Same case, blow molding. Blow molding is again a process where there is a two part of cavity where they use a small raw material. It comprises with a high pressure and it takes the shape of the mold which has been inside. Blow molding is moreover used for bottle kind of things. Wherever there is a development of the bottles, wherever there is a development of the cans and all, so blow molding takes the place. So in that case, you can directly develop the dies with 3D printer. If there is a die shape is a smaller shape, you can directly develop it with the 3D printer. Let, for example, a bottle of maybe that 10 rupees water bottle what we consume use, or 20 rupees water bottles. So that dies can be directly done by 3D printer, and it can be directly used because here the temperature is not that much, not high as compared to the injection molding. In injection molding, the liquids are into raw molten stage, but here there will be no molten stage of things. So here you can directly use the dies for 3D printing. And even there are a lot of material for 3D printing which can withstand a certain level of degree of temperature, around 100, 200, even for 300 degree also. So blow molding is one of the process where you put, why we make bottle kind of things, and you can directly use the mold making by 3D printer. So 3D printing is also helping in blow molding industry. Then comes up a point with vacuum casting. Casting comes up means, yes, there is a pattern making. So with 3D printer, how this vacuum casting is evolving? This is a casting. It's a process which has been used again for a batch manufacturing. If you require something as like a very good smooth finish like injection molding, so vacuum casting is the alternative for that, where you can trial out your product for 100, 200, 500 pieces, and vacuum casting develop this kind of silicon die. So first there is a master mold is made. The master mold is always done with 3D printer. The 3D printer, there is lot of castable resins are there, which has been directly done by master mold. Then this master mold is placed with top and bottom with silicon. This kind of rubber silicon has been put enough filled up with liquid silicon. Then this silicon is cut down into this kind of zigzag structures, cut into two pieces. You can see these two pieces. Then this master mold is taken out, and the impression of the mold is now here. The cavity and the core impression is here. And the same, now it has been closed. Again, there is a small orifice where we put the liquid material. It takes the liquid material, it gets open, and we get the part. So there is a complete process. So developing of the pattern with the with 3D printing is now one of the very convenient and a very highly accurate way for vacuum casting. You can directly do that. So this is the process what one of the students you are discussing about the wax thing. So how it has been working, the investment casting process. Investment casting is a process where we use wax injection. So with 3D printer, let for example, we do this kind of wax part. This kind of wax part has been developed, which is a master of the thing. Then after we develop a tree, we develop a one kind of tree has been developed where you put all these assembly parts. All these assembly parts has been developed. All this has been put. Now this is a complete rubber tree, complete wax tree. These parts are printed up with wax. This has been printed with assembly drawing like this kind of thing. Then this has been put into a plaster of Paris solution. Okay, you know plaster of Paris, ceramic. Everybody knows that.
Yes, sir.
Then this is put into a plaster
Yes,
of
sir.
Paris
In
solution,
the
which is a
statue and
yeah, it has been used for making statues and all. So plaster of Paris solution, being in ceramic, plaster of Paris can withstand a very high amount of heat. Okay. So once it's been dipped into the plaster of Paris solution, it's been next step, it's been heated. Plaster of Paris can take a lot amount of heat. Once it start heating, the inside wax start melting. Okay, it start melting and it flowed out. Now you can imagine the inside part is hollow now. Only this plaster of Paris is there. Inside there is no wax because it has been melted and it's been liquid came out, right? Burnout has been done. So inside there is a hollow structure. Now the required material has been put into the plaster of Paris. Then this plaster of Paris got broke, like we have to break it out, and the required material is there. You cut the material from the tree and you form the product, finished products. So this process is more used for jewelry. For jewelry is now the biggest market of 3D printing. The jewelry with a 3D printer, earlier these jewelers, you know, the karigars and all, they used to do this wax cutting by their hand. They used to do this fine wax cutting by their hand, and it took the karigar to make a small ring or maybe a small necklace takes a week of time. But a machine now can do 120 gram of work per day. In gold industry, 120 gram is a very high amount. You understand? 120 gram a machine can do per day. So 120 gram is a very high amount in gold industry. So now this all the wax patterns are been done by machines with the gold industry, and the same it has been again casted by using investment casting with gold, and the later on now karigars are finishing the part only. So this is one of the process how 3D printing is coming up. A very big area of 3D printing is the gold industry. If you consider our Calcutta, so like the Ankur Hati is one of the Ankur Hati, Dongju, these are the areas where the gold people and the gold karigars are available, and everybody use 3D printer for their development of the new models. So these are the very industrial process where the 3D printing comes into the segment. I will show how 3D printing is now becoming a revolutionary technology. We'll play this video. It will show the different of categories of 3D printing, how it is changing the revolving sides of the 3D printing, like how the industry is moving up very fast with 3D printing. Everyone just have a very deep look into this video. This is a company, they have developed the complete bike with the 3D printer. Even the tires has been also printed with 3D printer. If you have heard about the company known as Michelin, that is a very big tire based company. They are going to launch 3D printed tires in 2023. Already the testing has been done. Some more research is going on where that will be a complete tubeless and complete damage proof tires which will be launched. You can see a small glimpse of here also. They have developed the complete bike with 3D printing.
Sorry to interrupt, Mr. Bhattacharya. Does this video have sound? Does it have sound?
Yeah, it has a sound.
It's not coming.
Complete full volume, sir.
So when you share the screen, I think there is an option you can optimize it for motion and video. I think in that case, the sound will come to us.
Just a second, sir.
So what you may have to do, maybe just take off the screen for a moment. Then you have to again share the screen. When you share the screen, there will be an option on the right.
Shall I stop the sharing?
Yes. If you can momentarily stop sharing, and then when you share it for new, then there should be an option towards the right hand side. Drop down list you will find. There will be option.
Just a second, sir. I will stop the sharing first. Okay, I'm sharing it again.
So towards the right side of your that share screen, you see there is a drop down list.
Okay.
You click on that drop
Optimize
down
for
list.
motion and videos, right, sir?
Yes. You choose that one. Then you see that speaker sound.
I hope everybody can then share. Yeah, I'm just sharing it again then. Okay.
Yes, please.
Yeah, is it visible now?
It's visible. Yeah. Can you please check the?
Just sir, can you see the wordings? It's like this electric. Can you hear the wordings?
Yes. Now the audio is it's audible.
It builds up objects instead of carving them out of a block. 3D printing is based on computer models. They could be scans of spare parts or entirely new products like this electric motorcycle. Here, the Big Rep team is building a prototype of the motorcycle that's to go on display 2 weeks later at the Forum Next trade fair in Frankfurt.
We still have a lot of work to do before the Form Next. We have to get the printers ready and print out lots of parts.
Almost all the bike's parts have come out of the printer, including the elastic tires, the frame, and the lights. Many components consist of biodegradable plastic made from cornstarch. The team needed just 12 weeks to get from the preliminary design sketches to the finished prototype. But they're still working out a few bugs. The engineers spent a year tinkering with the new printers, and now the machines can be installed in a production line and controlled automatically. That's an important step towards mass production. So far, 3D printing has been used mainly for one-off projects.
The great thing about 3D printing is that we can create parts that used to seem impossible. Classical manufacturing processes simply could not work with certain complex geometries, such as in furniture.
Or this gripping device for robots, which is based on the design of the human finger. The device is outfitted with flexible slats that provide a non-slip grip.
The fascinating thing is that our creative process is completely digital. Engineers can sit down at the computer and just design something, and their imagination is no longer limited by classical production methods such as sawing or milling.
This revolutionary new concept may well improve the ways that industry designs, manufactures, and transports its products. Chicago is home to a number of new high-tech companies, including Fast Radius. They print components that are precise and durable enough for use in the mechanical engineering industry. Fast Radius often uses plastic resins, which allow for faster printing. The process looks like something out of a science fiction film. The metal foot dips into the resin solution. The components solidify on the bottom, as if by magic. No molds are needed. Light sources inside the solution ensure that only certain parts harden and take shape. This process makes the product lighter and also uses fewer raw materials. The company's co-founder and CEO is Lou Rassi. Fast Radius is working with logistics company UPS to completely rethink the concept of supply chains.
Additive manufacturing will have a profound impact on how global supply chains work. We call it the fourth modality of logistics, in fact. What we mean is that through human history, we have moved parts in three ways: by ground, by air, and by sea. And now we have a fourth mode of transportation, and that is moving parts by the internet at the speed of light.
Digital production offers a tremendous freedom to potential clients. A global 3D printing network can provide products more efficiently. Transport routes are shorter, and there are no huge specialized factories. These days, 3D printers can make just about anything, and robots automatically supervise the assembly lines. These machines can print single pieces or entire series of products, 24 hours a day. But so far, 3D printing accounts for only a small percentage of global manufacturing sales, which now total about $12 trillion. Revenues for the 3D printing industry in 2017 were only about $7 billion. But over the next 10 years, sales are expected to reach $100 billion. A lot of spare parts are now made by 3D printers. Companies can simply scan and store the components instead of keeping them for years in warehouses, and they can print new parts whenever they need them.
How many data points do we get for this part?
From each scan, it's in the millions of points that we're gathering.
Yes. So now 3D printing has been developing with various aspects of like various different industries, like as we saw with the automotive, then after with some of with the prosthetic based, then after now the robotic arm. So these are the some of the key part of the industry. I will just put a bit of the forward with the video. I will show you the main key sectors, and we will move for the more presentations. We are very shorter in time today. So like see, this is one of the company with the bigger parts development. So their application was light.
It allows goods to be produced in lower quantities, more often, closer to the point of consumption. That's going to radically change the supply chain, and UPS has to be able to change with it. And so that's why we're investing in this area, because we want to be part of this evolving ecosystem.
Many products will no longer be mass-produced. They'll be printed individually to meet the specific needs of clients. That will help to eliminate overproduction and long transport routes. 3D production also offers a number of other advantages.
If you're producing for an audience of one, so a custom shoe or a custom knee or a custom ortho.
So like now, the company, they are using 3D printing for their inventory and for their complete virtual stock also. Like for example, if you are being a company, you need to put a huge inventory in your companies for maybe the spare parts or some of the customized things. So there is a huge area has been consumed of your industry as like as a storage or like as an inventory management. So now the various companies are using 3D printer on demand production. Like one of your spare part is damaged, you tell to the company, I need the spare part. Company will immediately print that spare part with metal, required material, and they will send you within a day or within a two, as depending on the urgency of the material. yes, they will be putting certain amount in stock, maybe 5-10 pieces, not like in a lack of pieces. Companies are now putting 3D printer except of keeping up the inventory. So inventories are becoming now into a virtual form. So from any part of the world, you can access these machines or you can control the machines, and you are just putting a command to the machine. These machines are printing and the inventory is getting less and less.
Materials can withstand extreme pressure and heat, so they could be used to make weapons. In 2013, some Israeli reporters used a 3D printer to make a handgun and then tested it.
Just about a headshot.
Later, the reporters smuggled the gun into the Israeli Parliament building in Jerusalem. The gun had a metal firing pin, but security devices failed to detect it. Israeli Prime Minister Benjamin Netanyahu was attending a ceremony in the building. The reporter who had the 3D gun was seated just 10 rows away from him and even pointed the weapon at the Prime Minister. Netanyahu's office later criticized the reporter's actions as irresponsible. The Hamburg district of Finkenwerder is home to an Airbus factory. The head of the company's Emerging Technologies department is Michael Zillus. His team uses 3D printed prototypes to help improve components.
Additive manufacturing definitely has the potential to change the entire value chain. We can do production on site, redesign processes, and print on demand. We can develop completely new products for next-generation aircraft.
This is where Airbus assembles its A350 passenger jets. A key component is now being printed in quantity, the door-locking shaft. They're due to fly in the aircraft later this year.
This component usually consists of 10 parts, but the Airbus version has just one. We've integrated several functions and reduced the weight. There are 2 of these parts per door, and they make the aircraft lighter by 4 kilograms. That's a lot in the aviation world. It cuts down on fuel consumption and CO2 emissions.
Over the 30-year lifespan of an aircraft, 1 less kilogram of weight will save 500,000 litres of fuel. The A350 actually has a lot of 3D printed parts. 16 door-lock shafts, 20 brackets for the crew cabin compartments, and more than 1,000 plastic parts in panels, ventilation systems, and electronics gear. Airbus is even testing prototypes of electrical parts. 3D printing is typically used to build grid structures like this cabin partition wall. The printed version uses less material and so is lighter than previous models. Airlines are always trying to reduce the weight of their planes to save fuel, but Airbus believes the 3D process could be even more efficient.
This is the largest component that we can make right now. We'd like to build bigger ones. It took us a total of 900 hours to produce a complete partition wall and 7 construction chambers. That means we had to start up a printer 7 times to produce the 116 parts we needed.
900 hours of printing time for just one wall. That's a lot of work. In future, the hope is to print a mold and then cast it again and again. Right now, conventional mass production methods can still produce components like this more quickly and cheaply than 3D can. But that could soon change. This is the Formnext additive manufacturing trade.
So now you can see, like with the Airbus also, they are using a lot of 3D printed parts in their aeroplane. Like with the material what I have shown to you, in which are like FSD certified, FFS certified materials like Ultem 9085, Ultem 1010. They are the one of the material which has been directly used. Yes, apart from that, they are also using metal parts. into the metal airbus. The Boeing is also using to reduce the lot of weight in the airplane. Like for a door knob or the door handling part, they are using 3D printing, which reduces two doors and at a weight of 4 kg, 4 kg, 8 kg of reduction. That saves a lot of fuel consumption for them, and obviously the carbon CO2 emission. So these are some of the factors what with the 3D printing is coming up with a very revolutionary way in different applications, with aerospace, with automotive, with consumer goods, and different segments. So I will just move forward with the video, and will complete going with the presentation. The video is a bit long, so we have a very shorter in time. So we will share the video with your team, with Vidut sir, and later on it can be played in your campus, and everybody can see it up. So now we will come into the core part where 3D printing applications lie, how 3D printing is evolving into the different applications. So first is automotive. So with automotive, we can develop a huge range of parts with 3D printing, like the complete engine body, which is the assembly of not more than even like it's the assembly of around 100 parts, which can be done with 3D printing in a very less assembly of maybe 2 or 3 parts. Like manifolds, with the exhaust manifolds with 3D printing, customized exhaust manifold can be done, which is a very impossible task for doing in your normal conventional way, and it can be directly implanted in your car or in your bike, in more of the racing cars and more of the high effective cars, which now people are using also. The entire body of the cabinet for their crash testing, or for the car dimensional testing, or for the car body testing, or for the EV cars, they are now performing the entire lot of body parts are with 3D printed parts, which can be directly implanted into the car for making it lightweight. And yes, again with the prototyping segment, developing of all the bumper, grills, and the dashboard, everything can be developed with 3D printer for their fit and for their aesthetic looks. You can see this much big 3D printer is obviously not available where you can directly print. So this has been printed into this kind of multiple parts. You can see this kind of jointed base part, and later on it's been painted so that it can give us a real finish. You can eliminate this joint parts and you can just directly get a core finish for that. So this is the both the segment which has been kept up. Then comes with the marine. So with marine also, a lot of people are using 3D printing impellers, 3D printing boat models. Even in the industry, if you go with the Google, already 2 3D printing speedboats completely developed with 3D printing has been launched outside, and they are completely running fine on the water. So now all the people are using 3D printing for developing in the bigger boat size machines. So there are robotic based 3D printers are there who can print this kind of big boats. And even with IIT Kharagpur, we have done some projects with the marine engineering department, where they have already printed some impellers in case of for testing of their ships and for the further development of the projects. Then aerospace is again a bigger segment of 3D printing, where this kind of shape optimized brackets, then after the casting replacement, then after the ESD ducts and the pump outlets and all things, which can be directly done with 3D printer, and it can be put into the flight. Once if you students or all are invited, obviously you come to our facility. We have this complete jet engine assembly in our facility also. We can show you that. And this all the parts which has been used for aerospace are now using by the big companies, and now they are developing it by 3D printing. Medical is again one of the bigger application of 3D printer, where developing of this kind of anatomical models, realistic models like this kind of cranial plates, then after the surgical guides, then after the surgical model, or for the pre-planning of the surgery. If you are doing any surgery with a doctor, by seeing the CT scan or the MRI scan data, they can't identify the real challenges which is going to be faced. So usually now with 3D printing, doctors are developing the real patient anatomical models, which are very, which are like a replacement of the anatomical models, and doctors are pre-planning the surgery on that. They are cutting that model and they are getting the realistic feel, what is the real stage of the patient, and they are performing the operation, which helps the doctor to reduce the surgery time, reduce the blood draws. Obviously the patient recovery time get increased, and these are the factors which are coming up in medical industries. So this is the complete segment where we can do what we can do in medical. First will be the implant surgery, where you need a cranial plate. A lot of damage, a lot of accident challenges comes up, where your brain top part has to be replaced with a metal part, and this kind of metal part has been now printed with 3D printer, and it can directly replace to the human body. Directly, it can be printed with titanium and it can be replaced. Then maxillofacial models, the patient, those who are having any surgical base into their mouth or mouth-based things where cancer has been happened and your certain part of the mouth has been cut down due to the cancer. Then after the pre-planning of the surgery or the reconstructive surgery, the plastic surgery, what we say, plastic surgery people, they use this 3D printing models of the patient for reconstruction of the body or the reconstruction of the model. Then after the cardiovascular is the heart surgery patient or heart surgery doctors, they use for the locating the exact block criteria or exact things for the heart surgeries. Then are the musculovascular, like those who are into developing into the bone segment, those who are using the bone part, so they use this kind of model for their developing into the models. Then neurologists or the digestive system, then the kidney based doctors or the digestive intestine based some surgeries can be done. Then the urology people can do directly 3D print. And this is the model, if you can see this, we have done for the Calcutta Fortis Hospital. So where there is a this yellow part is the tumor for a patient which has been there in the kidney, and they want to operate this yellow part. They want to know the real position of that. They want to know the complexity of the surgery. So we have supplied this model to the Fortis Hospital, Calcutta. Even with the neurosurgery, also developing with the tumors or with the complex neurosurgery, doctors are now using 3D printing models. Dental is again the biggest segment of 3D printing, where dental surgeries, dental guides, dental surgical tools are being now used by 3D printers. So where this kind of dental clear aligners, have you seen people wearing this braces into the mouth? Have you seen that all? To make the proper alignment of your teeth, they put a teeth braces like steel kind of wire into the teeth. Have you seen that? Anyone?
Yes, sir.
Sorry.
Yes, sir.
Anyone have you seen that?
Yes, sir.
Yeah. So with that kind of braces, that has a lot of disadvantages. So that affect your mouth. That doesn't look good. Also, everybody will be teasing up you, and the food got stuck into that braces, and it affect your inner teeth and inner tongue and all. It got cutted down. So nowadays, that braces has been replaced by these clear aligners. This has to be printed by 3D printer with the clear aligners, and the doctors will fit into your teeth. This will look like a real teeth of the same, because it's a completely transparent part, and that comes a new advantages of 3D printing, how it is clear aligners in the market. Now people are don't using that braces for the for their daily to daily life uses. With this implant kind of drill, lot of time for implant in the metal implant, for teeth implant, doctor has to drill your teeth. So this kind of surgical guides can be used, where they can use it for the proper positioning of the drill. We are also developing in our facility. We have a lot of parts for this. We have a lot of dentals, those who are coming up to our facility, and they are doing this. Another application will be the prosthetic part, where already we have covered this, where developing of the customized prosthetic, customized hand, customized leg. So there is a lot of companies in Calcutta also, like Vispala is one of the bigger company for prosthetic hand development, and we used to print the part for them. So these are the some of the things what we are doing with prosthetics also. Engineering, any kind of engineering work from coming up from a basic mechanical to all segment of engineering, for electrical, electronics, printing of the casings and all, for electrical casings, electrical bodies, we can directly do with the 3D printing parts. With architecture, so this is some of the architectures are using for their development of their models and all. Recently, we have done a project for a Westin. This hotel, have you seen this in Calcutta? Anyone who has seen this hotel? Anyone? Nobody has seen this hotel. This is a Westin hotel, which is just opposite to the Eco Park. Opposite to the Eco Park, this is there. So we have developed the small model for the Westin for the people. They have asked for the small sample models. So like architectural model, this kind of model can be directly developed with 3D printing. So the use cases for how the use cases already we have discussed for this of the use. One of the cases with the Boeing, how the seat belt weight reduction has came up, which comes up into the cases of around 40 kgs of weight reduction we have faced on the part. So these are some of the cases already we have discussed on the aerospace. We'll move forward with the rapid tooling segment where rapid tooling part has been used. So like this kind of part where the metal casting with FDM pattern has been used. So they have done the casting with pattern with FDM, and then they have done the casting in metal. So some of the parts in vacuum casting. Then after this is the bicycle holder in the back of a car. Like it's like using as a tool, as like a jigs and fixture. This is a complete fixture for an inspection gauge, lightweight jigs fixture for the inspection of a part. You can directly print a fixture and you can put your part for the inspection purposes. The Indian pump manufacturer, I hope a lot of companies know about this. This is a case study with Compton Gibbs. Compton Gibbs, you know, I hope everybody knows about the Compton Gibbs. For the pump development, for the pump impeller development, for the pump body development, they use 3D printing for their conventional process to submit on the segment. So the time required for prototyping with the conventional is 2 months. With the 2 months it take for developing of the prototype by making up with the CNC machines and all, which come down, see the cost difference, which is come down, which come down to 2 weeks. So the traditional manufacturing did 2 to 3 months, and which comes down to 2 weeks, which is around 83% of the time saving, and it's around 50% of the cost saving. So how 3D printing has been used by the Indian pump manufacturers, Compton Gibbs, and a lot of companies are now using this 3D printing techniques. So this is again with the lab where they are using this joystick, customized joystick. They are using, as one of the question comes up, can we do the batch manufacturing in Polyjet? So this is one of the case where the batch manufacturing has been done by Polyjet. Around 50 jobs on the next day they required with the customization of each the joystick with the each color and each different things. So they use Polyjet printing for their purposes, and they have supplied to the customer. Anybody know this statue? Anyone? Can you tell me?
Statue of Unity.
Sorry?
Unity.
Statue of Unity.
Statue of Unity, right?
Yes, sir.
So this is the India, even
It
not
is
in
Statue
India,
of
this is the world largest statue, right?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. So this statue, for developing this statue, this is the world largest statue with 182-meter height on the part. So this is one of the biggest thing, and they use 3D printer for their wind testing. They have scaled down the model. They have done the entire 3D printing model. This is a 3D printed model. They have done the wind testing. From this, there is a wind panel. The wind has been coming. They have done the wind testing. The RWDI, who was in charge for this, they have used Stratasys printer. The director of RWDI, they have printed this in Stratasys, and they have used it for their wind testing purpose, key, how much wind pressure or how much thing they can withstand, and what angle and what things they have completely analyzed with the 3D printer only. Then after, these are the major segments of 3D printing where 3D printing is coming up into different uses. These are the medical devices, automotive parts, automotive interiors, your daily to daily life beverages, or your packaging goods, or your hearing aids, sunglasses. These people, everybody is using 3D printing for your aesthetic look testing, for your functional testing, for your fitment test. These are the complete summary of the application where people are using for art and architectures, for miniature model, for architectural models, for dental, for medical. So people are using this 3D printer in different segments. This is a 3D printing is a sum of the technology which can fit into any kind of production, any kind of manufacturing things. This is a shoe sole. Already shoe sole we have discussed, like developing of that customized shoe sole we can directly do with 3D printing. This is a gas turbine research establishment, GTRE. Everybody knows about GTRE? Anybody? GTRE के बारे में पता है सबको?
Yes, sir. DRDO.
It's a gas turbine research establishment of India. So they have developed this 3D printed part. This is the engine, Tejas engine. You know about the Tejas engine?
Yes, sir.
Jet engine, Tejas jet engine. They want to go for an exhibition. So they have done all parts, all there are around 25,000 parts are there, 2,500 components are there, which has been completely 3D printed, and they have taken it to the exhibition. This is a Kaveri jet engine, and it's been used in Tejas plane. See, with FDM, with traditional manufacturing, the cost was around $60,000 and the time duration was 12 months. And with 3D printing, it came down to $20,000 and the time duration came to 1.5 months. So they have saved 40%, $40,000 in cost and 10.5 months in time. So this was the Indian case study only. These are which has been used and which has been successfully delivered. This is again with a pump transmission company. It's a German-based company's Indian part where they are using this pump transformation things with 3D printer so that the costs get down and down. You know about this part? Can you see on the left hand side? What are these? This is your casing for the ATMs or for the metro rails management system. These are the casings. So they do first with 3D printer, they test all the things, then after they go for, here we put the metro card and it will show us like how much balance is on our metro card and all. You used it, right, everybody?
Yes, sir.
So this has been used first. Then after this is a helmet for the Steelbird. Steelbird is a big company for helmet, right? These are the helmet of the Steelbirds. They use 3D printing for their prototype development. Once the testing and once the design is validated, then they go for the traditional manufacturing. So a lot of companies are now using 3D printers. I'll show you some medical cases, how medical things are going on in 3D printing. First, we get the medical data, which is the CT scan data. Then after it's been converted into the 3D printing data and it's been printed by the 3D printer. So it's a hospital cases are there where they are using for nasal swab, where they're using for heart surgeries, they are using for as a surgical guides. These are the real images, okay? They are using for as a tooth drill operations. You can see this yellow part. This is the surgical tool guide for printing. These are the clear aligners, as like same as like teeth. They will be putting into your teeth. During the COVID time, 3D printing comes very good into the part where the developing of this kind of visors, dye, mold, then after the printing of the swab for the hospitals, printing of this face shields and all. In COVID, 3D printing put a very big action. So this was some of the part for surgical into neurosurgeons, where for a neurosurgery, this is a tumor which has been printed into clear and semi-rigid structure. These are the nerves which has been printed into soft tissues. This is the skull body, and this is completely done by Polyjet. Polyjet has the ability to print multiple things in a single go. So this is how Polyjet prints. It deposits material into multiple things. We have already seen this kind of videos. This is again the kidney surgery for the Department of Fortis Kidney Hospital. We have already mentioned for you. So these are the tumor which has been in the patient part, and we have developed different angles and different patient data are there. These are the 3 different models for 3 different patients which we have developed for Fortis Kidney Hospital, Calcutta. So they have done the surgery accordingly as per their requirement. With automotive cases, we can directly develop a lot of parts for automotive, like this large kind of mirror prototype, wheel arch, and the large fenders, large covers, spoilers. Directly we can do this kind of thing for automotive. This is a tractor company known as John Deere. John Deere is a very big company. I hope everybody knows about John Deere. John Deere is a very big company, US-based company. They are developing very heavy equipments like tractors, then JCB machines and equipment machines and all. So they use 3D printer for their interior and exterior part developments. This is the interior part, the table trays, the AC vents, cup buckets, armrest, everything can be 3D printed, the camera mounting. These all can be 3D printed for the lighter in weight and lighter in consuming parts, and everything can be easily replaceable also. This is with a normal automotive segment, what we use, the normal cars and all. The entire bumper, grills and everything can be 3D printed and can be tested for their crash testing, for their prototyping, fit and form testing, functional testing. Then they go for the real category of molds. Same as with the automotive. This is a case study with Audi. Audi developed this with 3D printer. They print the tail lights, they print the indicator lights and everything with the 3D printer, and they check it with the fit and form testing. Then they go for the final production. These are all 3D printed parts with the color. So this is something how 3D printing, what are the application works and what everybody do with the 3D printing part. So this now we will come up with our offerings, what we offer in our Center of Excellence. So we offer a state-of-art facilities on 3D printing labs. We have a CATIA lab for designing. We offer cybersecurity, we offer data science, and we offer embedded systems, IoT. So we offer the entire Industry 4.0, all the pillars of Industry 4.0, the 4 pillars which are lying up. First is additive, second is cybersecurity, third is data science, and fourth is embedded system. We provide courses on all the topics. 3D, today we will discuss on the 3D, how we will be providing the training and what is the core expertise to us. We provide the complete training into emerging technologies of the training, where 3D printing is one of the biggest part into the thing. We have all 7 categories of machines. We have all procured machine from Stratasys. Our certification comes from Stratasys. The person, those who will be trained from here, they will get a certificate from Stratasys and a combined certificate from Stratasys and Webel, which is like a first thing which comes up in India, where a company from US and company from Israel, they are certifying the persons for their certifications. We run a certain level of courses. So even for our designing, we get the certifications from Dassault Systems, and where Dassault certified the people for their excellency of the course on the certification. With 3D printing, this is our state-of-art facility. All the 5 F-series printer, which is the Stratasys industrial printer. Then after we have Photos, the bigger one, which is a production series printer, and a Polyjet printer in our facility. We also have a 3D scanner, which is from a Russian company, Artec. And then after we have CATIA Dassault system designing software. And these are certain range of material what we do in our 3D printing. So this is one of the world-class facility. Everybody will be surely please come to our facility and have a visit. So our training modes, there will be 2 kind of training modes. One will be online sessions and a hands-on training mode. We have different categories of program, 2 to 3 days workshop, 10 days certified courses, 1 month certified courses, and 6 month we have the main certification of 6 month courses, where industrial partners will be there, and industry partner will certify the course like Stratasys and Dassault system. And then after we have some customized courses also, where maybe a student is required or maybe a corporate person is required, particularly dedicated with 3D printing, particularly a segment of courses, we can do the same for them. So this will be the summary for today, what we have learned, what is 3D printing, difference between manufacturing, additive and subtractive, what kind of material, how different technologies of 3D printing is working, and how the additive manufacturing workflow is there, from design to machine to materials and all. So we will end from my end. Any questions now, please? Any questions, students, everybody?
Sir, I have one question.
Yeah, please.
Can you hear me?
Yeah, I can hear you.
Sir, if we want to some hands-on practice, actually we don't have this type of too much 3D printer in our institute. So we have some opportunity to work with you.
Yeah, sure. We can plan that. Vidhu sir is there, and I hope Aniban sir. Are you there, Aniban sir?
Yes, sir. Yeah. So I think what it was Dave, right, who asked this question. So yeah, we'll look into that. I think let us come for, if there are any other questions, let us finish with this question and answer session, and then what are the possible options of like how we can engage this particular organization, how we can associate and collaborate with them. I will look into all those possibilities later on. But I think definitely we are going to talk in details with Mr. Anirban Chaudhary or Mr. Kutim Bhattacharya. What are the possibilities in terms of training, in terms of internships, etc. Okay, so if there are any other questions, technical questions, based on the
Any other
presentation
questions, please?
made by Mr. Kutim Bhattacharya, so please carry on with your question.
Anyone? So we can then close from my end. Okay. Thank you, everybody. Thank you to give us the opportunity. Thank you, everyone.
So no questions from the student?
Sir, I will stop sharing my screen.
Yes, please. So, Pataksi or Tanishka, can you please share our screen and continue with the proceedings? Okay, so on behalf of the department and on behalf of the Centenary Celebration Committee of the Department of Mechanical Engineering, IIST Shibpur, I take this opportunity to thank today's resource organization that we have able to be some our Center of Excellence, particularly Center Manager Mr. Anirban Chaudhary and the speakers Mr. Kutim Bhattacharya. Also, we had Mr. Maqsudur Rahman with us today for their very excellent and enriching sessions on 3D printing. I'm sure that our student community has been benefited immensely from this particular session. In this particular session, they have covered a wide range of technologies related to 3D printing and what are the different materials that can be used to make parts using 3D printing technologies. Also, we have seen different applications in aerospace, automobiles, medicals, biomedical applications, etc. So it has been very enriching. Really, it's a very long session for Mr. Kutim Bhattacharya. We can understand he has been continuously speaking for about 3 hours. So we thank you very much from the department and from the Centenary Celebration Committee, and also from the IIC, Institutional Innovation Council, that we have come forward and we have been associated with this particular event that we have planned for. So our sincere thanks to you. With this, I mean, we do have some certificate of appreciation for the speakers today. So obviously, I would like to present it virtually to the speaker, Mr. Kutim Bhattacharya, for your wonderful session, very enlightening session on this particular technique, 3D printing and technology and applications. Then also we have Mr. Anirban Chaudhary, he is the center manager at the Global Para Center of Excellence in Industry 4.0. It was, and we had long discussions with him how we can continue with this particular event, and finally we have been able to make this particular event. And also we had Mr. Maqsudur Rahman from the Center of Excellence in Industry 4.0. These are all certificate of appreciation that we are presenting in virtually, but we have planned to send these certificates in hard copies in the near future. And also we'd have from our side, there will be a small memento as a token of appreciation from our side. So again, that we'll be trying to sting you this through by email. So with this, I really thank you, this particular organization, for their association with us and for their time, for their various Professor Ghosh was mentioning at the end of the session that this particular session has been conducted by them on free of cost. So it's a very big thank you from our side, from the department, that you have come forward and you have delivered this particular session. So with this, I think we also must thank you all the students for participating in this particular session. I understood that there were not many technical sessions because not many questions from the technical side, because the presenter maybe they have asked during during this presentation he has asked lot of questions, and you have taken part. You have participated in those question and answer session during presentation itself. But if there are any feedback that you would like to let us know, like how did you like about this session, if you can have some feedback, you can also please let us know. Any feedback from the participants?
Session was very enlightening and interactive too. Like we had our chances to speak and discuss and learn about a lot of things. So it was very enlightening and good awareness for us.
Okay, thank you, Tanishta. Anyone else want to leave some feedback? Then, Mr. Anirban Chaudhary, are you available? Sir may have left. Maybe he's busy. Okay, so with this, I thank once again to the speakers for this session today, and the students who shown interest and attended this session. I hope you have been benefited from this particular session. And I also thank our support team, our student team, who have contributed to make this webinar happen. And also our support team in the sense, Dr. Santanu Das, Additive Mandal. Thank you for their continuous support in hosting this event. And also our IT support team from the Institute, and so many continuous support throughout this Centenary lecture series, and also these different workshops that we are hosting as part of the Centenary Celebrations. We thank you very much from our heart for your support on this event. So with this, I think we come to an end of this session. So thank you for joining. Have a good day. Thank you very much.